and namaste everyone. Welcome to DNX 2022, Globant's premier conference on data and AI. I'm Sanket Deshmukh, working as a senior data scientist with Globant.
I am Priya Badlani. I'm working as a business intelligence engineer with Globant.
I am Shikha Rani, working as data architect here at Globant, and we will be your host for the evening. This year's DNX is all about empowering organizations through augmented analytics and implementing frameworks for responsible AI.
AI technologies are creating breakthroughs in almost every aspect of our ecosystem, and we need to start utilizing these to bridge the gap between this huge clutter of data and effective decision making.
Before we begin this exciting journey, here are some important points to remember. Please share all your queries using chat box. Please keep reposting with hashtag DNX2022 on LinkedIn, and most liked LinkedIn posts stand a chance to win exciting goodies.
We would like to invite Gonzalo, Shivraj, and Avi to deliver the keynote and kick off the conference.
Hi everyone, my name is Gonzalo Sarza and I'm the studio partner at Globant, head of data and AI at Globant. And I would like to thank you for joining us as part of this 2022 Data and AI Next edition. I'm confident you will enjoy the conference. This year, we will focus on two extremely important and relevant topics: augmented analytics and responsible AI. As you probably know, the remarkable advancements in data analytics and artificial intelligence have fostered the widespread adoption of machine learning and advanced analytics within many products and services that we use and consume on a daily basis. However, implementing machine learning solutions is still a complex endeavor, and many organizations are struggling to fully exploit the strategic advantages of AI and truly become data-driven. Nowadays, there are two main topics that are constant for companies to become data-driven and to democratize the access to data and to be effective in data-driven business decision-making. On one hand, to carry out augmentation and automatization of analytics, primarily through the use of machine learning, natural language processing, and advanced data engineering techniques. And on the other hand, to make responsible use of AI, harnessing and mastering the governance, the monitoring, the processing and computing, and also the sustainability of data with a strong focus on ethics, fairness, and transparency. In this conference, you will be able to see, to understand, and also to learn from experts and thought leaders from both Globant and some of our partners on how to augment analytics and to make a responsible use of AI to digitally transform organizations. So please enjoy the web conference and thank you for joining.
Good evening, everyone. A very warm welcome to all of you to this amazing web conference on DA and AI Next. I will first congratulate all of you to really find time for this. This is an investment in yourself. This is an investment for your own future. We know that a lot of conferences happen throughout the year. Why is it important to attend any of these conferences? You'll realize that these are opportunities for you to get a great food for thought. At the same time, I think open yourself to new opportunities, new possibilities. Why is that important? If you see how this whole IT industry has been evolving, you'll see a major demand of true transformative challenges, true transformative programs that are required by all industries. We are seeing a major disruption across industries, and what they're looking for is a true transformative engagement with most of the customers. So what we need to think of is what is the role of data AI in this in terms of the business impact. We've come a long way in terms of the advent of really good hardware, pushing further the limits of what we can do with AI and machine learning. What we really need to now see is what is the real impact on business and what is the tangible output in terms of business that we can bring with some of these ideas. So throughout this whole sessions, you are going to hear about some really new frameworks, some really new ideas around data architecture and AI. What you really need to also do along with this is start translating this into business impact. If you're able to do that, you're starting to think how you're going to implement and what is the true potential of technology that you will leverage. So I know this is going to be not necessarily tangible and implementable within the next, let's say, few days. You're not going to be able to go out and really implement something just because of attending this. But at the end of this, this will open up your mind to new possibilities. So this becomes an investment towards that. So I really want to congratulate all of you to invest this time in yourself. There are some amazing talks today. Just to understand the plethora of impact, right? Burger King, which is a fast food joint globally, has recently hired a chief digital officer. The reason why Burger King, an industry which is so far away from digital, would want to hire a chief digital officer is the ability to impact the complete experience and a complete reinvention of their digital aspects, right? And that not necessarily only needs a fancy user interface or a backend, but what is really required is that engagement with the customer, is the real understanding of data of their customers, and that only happens with the right usage of the latest technology. So always remember, with data is always been this whole push and pull, where the latest technology will unlock a lot of new solutions, and new solutions that we want to really use will further push for new technologies to be developed, right? So I think what I would definitely urge all of you is to start thinking business terms of data, start thinking of what is the true impact on the industry that is happening today. At Globant, we are focusing heavily in terms of the complete reinvention of domains, completely reinvention of industries, and focused heavily around data and AI. For us, data and AI is not a mere buzzword. We want to focus on creating true applications and, like I said, unlocking new avenues for revenue. This is what truly makes our partners relevant for the next two generations to come, right? So let's all have an amazing evening today. What I would definitely urge all of you to make this very, very interactive. Please ask all your questions that you have. Do not wait for the end to ask all your questions. There might be different ways and mediums where you can post your questions. So make this as interactive as possible. And believe me, at the end of this, this is going to be a truly great investment in yourself. So welcome again to this amazing web conference for Globant. I would not take a lot of time from all of you because there's so much amazing content coming after this. So I'll hand it over back to the team. Welcome all of you to this. Thank you.
Hello everyone, I am Avijit Datta and I head the Data and AI studio at Globant India. Last year in October, we had the inaugural edition of the Data and AI Next. The theme of that conference was Digital Primacy through Data and AI. We had some of the amazing sessions such as using AI to model the uncertainties of the financial world, disrupting business transformations through data, how to bring scalability in AI solutions, just to name a few, which were being delivered by some of the amazing speakers from Globant and across the industry. The whole idea for our first edition was to showcase the transition from digitization to digital transformation and then finally to digital primacy. As we understand, in order to achieve digital primacy, it is important to align the business with technology in a collaborative environment where these two not only complement each other but also augment together. Of course, AI and machine learning sits on top of this ecosystem to achieve the predictive and prescriptive analytics for making this transformation journey more coherent and sustainable. But none of this would be possible without having a clear and implied goal of reliability, trust, and responsibility. And that, ladies and gentlemen, brings us to the DNX 2022. This year, the theme of our conference is Augmented Analytics and Responsible AI. As companies mature on their journey to become truly data driven and democratized, it is inevitable for them to carry out augmentation through the automation of the analytics processes. And this is done primarily through the usage of machine learning and natural language processing. In the journey to become self reliant on data, companies put more and more algorithms to production. This introduces governance, management, maintenance, and sustainability aspects all under the umbrella of ethics and fairness. Setting up the right knowledge management and domain specific practices makes the companies truly responsible and augmented in their data analytics journey. Although digital primacy can be achieved by truly harnessing the power of machine learning and artificial intelligence, it is equally important to ensure that these solutions are reliable, trustworthy, and responsible. And at Globant, we are helping our customers to achieve that goal. How? Over the past 16 years, we have been helping our customers to discover, define, and develop data strategies and data products that are aligned to their business needs. We help business with data driven evolution, where they can understand the capabilities as well as maturity of the data through our proven frameworks. We help the businesses to create hypotheses for the business models and then build rapid prototypes to validate those hypotheses. Finally, industrializing and productionizing these prototypes in the form of commercially viable products. Our goal is to constantly help our customers to augment their analytics journey by creating AI and ML products which are not only desirable but also responsible. And we do it through our data driven frameworks and accelerators to not only spearhead the time to market of the data products but also making sure that these products are reliable and responsible. We have built some of the state of the art accelerators in the space of MLOps, edge computing, and federated machine learning. You can find some of those innovation videos as a part of the description of this video. Next, we have got an amazing lineup of sessions today, starting from Ashtang AI to Explainable AI. And then we'll be talking about how no code, low code platforms are augmenting the analytics journey of an organization. You will see how Web3 is going to impact AI and ML world. And finally, we'll talk about how data mesh is acting as the next frontier in the creation of an effective data strategy for an organization. I'm sure all of you are going to gain a lot of knowledge, diversified knowledge, and you're going to thoroughly enjoy this conference in the similar way we did in creating it. With that, I welcome you once again to the DNXT 2022. Thank you so much.
Thank you, Gonzalo, Shivraj, and Avi, for your warm and delightful welcome.
Have you ever wondered how we can use AI to improve the lives of people who sit at the bottom of the pyramid?
You mean using AI in agriculture, smart cities, or manufacturing? That is an interesting yet daunting task which is in need of an hour. In the upcoming talk, we will explore the Ashtanga or 8 different types of AI capabilities needed to complete an end-to-end AI stack.
Let me introduce you to our esteemed speaker, Dr. Shailesh Kumar. Dr. Shailesh is distinguished scientist and visiting professor in ML for ISB Hyderabad. In his current role as Chief Data Scientist at Reliance Jio, he's heading the Center of Excellence in AI and ML. Please give a big round of applause, ladies and gentlemen, Dr. Shailesh Kumar.
Hello, everyone. This is Dr. Shailesh Kumar. It's a pleasure to be here. Today, I'm going to talk about a framework called Ashtang AI that I've been working on. This kind of sums up the different kinds of roles I have played in different industries across the last 20 years of my career. And the goal here is to actually think about two key ideas. One is, what are complex systems, which are the systems of the future? And how do we think about AI not just as a set of models that get trained and deployed, but how do we think about the AI stack and an AI architecture for a complex system? Now, when I talk about complex system, quick introduction for myself. Currently, I work as a chief data scientist at Reliance Jio. We are also starting a program in Geo Institute on AIDS this July. And I am also visiting faculty at ISP for the last 10 years. All right, so let's get started. So if I think about the different ways people understand and talk about AI, right? So some of us talk about AI from an algorithms perspective, right? So different types of AI frameworks are available: supervised, unsupervised, reinforcement, deep learning. Then we can talk about AI from a data perspective, right? How do we apply AI to vision, to speech, to text, to transaction data, time series data, and so on? We can also talk about AI from a process perspective. You clean and label the data, you do feature engineering, train the models, do A/B testing, and then you deploy the model and do inferencing. There's another way to talk about AI, which is about domain, and say, how do we apply AI to healthcare domain, agriculture domain, education, telecom, retail, and many other domains, right? So these are different ways people talk about AI. I will not talk about any of this. I will talk about an architectural perspective on AI. And the reason for this is when I saw how people think about AI, the view is very narrow. We think of AI as a very narrow thing, which is to build some models and do some inferencing with them. And but really, if you think about the overall construct of AI, it is very broad and vast. And I wanted to cover that. And to do that, I thought I will layer it in a similar way that we have layered the network layer. For example, if you go to networking, there are 7 layers in the network stack. So similarly, here we'll talk about the 8 layers in the AI stack, and hence the Ashtanga AI. But before we go there, let me talk a little bit about why we need this. Why are we talking about AI in this way? And if you look at the product 1.0, right, the products that our parents got excited about, they were, cars and washing machines and what have you, air conditioners. And these products came with what we call, programmed intelligence. Then came product 2.0, which is all the digital products. If you look at Google Search, Maps, YouTube, Netflix, LinkedIn, and all that. So these are product 2.0, which basically taught us how to build planet scale products using some core APIs and scale them and make it available to the whole planet. So that is product 2.0. Now we are heading in the next 20 years into what we call product 3.0. And these are what I call complex ecosystem products. So examples of these products, so think of an entire smart city as one product, or think of the entire telecom network, not just one phone or one cell tower, but the entire telecom network of a country as one product. Yeah? The very complex refineries and manufacturing units, the entire plant as one product, not one unit. How the whole thing works as a whole is what we need to think about. Similarly, if you think about the agricultural ecosystem of the country, not a single drone, but the entire supply chain, fertilizers, seeds, crops, everything, and how does that work as a single whole is a complex ecosystem. Similarly, if you think about healthcare, not just one hospital or one MRI machine, but the entire healthcare ecosystem of a country, how does that work? And if you think about e-commerce, this is where we have already made a lot of stride in terms of how to think about this as a complex ecosystem, right? So these are examples of the next 20 years of products. And the problem is there are no operating systems for them. So there is no common operating system which can handle this level of complexity. Uh, and operating system both from a IT and automation perspective, as well as from a AI perspective. So this talk is really about the AI perspective for building such complex ecosystems. How do we need to think about them in a different way than what we do today? So what characterizes a complex ecosystem is things like, they have billions of entities of hundreds of types. So if you look at telecom, there are customers, people, devices, all kinds of sensors, cell towers, facilities, all of that, right? Similarly, these complex systems are having trillions of interactions all the time, and they're asynchronous, they're just happening, right? So if you think about people calling each other, people downloading data, uploading something, people using different applications, people joining the system, leaving the system, changing the SIM, making the payments. These are all interactions happening all the time, every day, right? So it's a very complex system from interactions point of view. Then if you think about the metrics, it's not one metrics that we are chasing. In Google search, we are chasing only two metrics, right? How good is your search click-through rate and how good is your ads revenue? But in a complex system like this, we are chasing many, many metrics, right? Is the customer happy? Is the customer valuable? Is the operations going well? Is the utilization high? Is the process streamlined? Is the business making money? Is the environment um, getting impacted? So we need to think about many, many metrics together as a whole. And this is one of the things we'll talk about later. Uh, then these have millions of decisions happening all the time. And these are variety of decisions, customer facing decisions, market facing decisions, right? Sales and marketing, logistics and supply chain decisions, operations decision, maintenance decision, and all of that. And then there are many, many workflows that are running. And I can classify them as execution workflows, which are the daily execution of the systems. efficiency workflows that are constantly looking for sources of inefficiencies, expansion workflow that talk about how we can expand the business, how can we expand the infrastructure, and where to do it next, and exception workflows, if there are problems, how do we handle them, right? So this is the definition in my mind of what is a complex ecosystem. And the key idea here is we don't have an operating system for something like this, and we need to think about that so that we can build such a system, vertical after vertical in the next 20 years. All right. So now let's switch gears. Let's talk about the what. So we've talked about the why we need a framework like this, uh, because we are heading into these complex ecosystem products. Now what we need is to think about AI at different levels. So I'm going to call it Ashtang AI. Asht means 8 parts, like we have Ashtang Yoga. And layer 0 really is not part of the Ashtang AI framework, but it's a very important foundation layer. So even today in the 21st century, a lot of data is still not digitized. So our students are still writing on a notebook. So that data is not digitized. Our doctors are still prescribing medicines on a piece of paper. That is not digitized. Our farmers are still writing logs on their registers. If they are, that is not digitized, right? So a lot of data, your blood reports are given to you as printed data. ECG is printed and all of that. X-ray is printed. So a lot of data needs to remain digital and get digitized, right? Another example is invoices that are printed and shared in PDF format. That is also not digitized, right? So how do we think about digitization layer first? And although this is the beginning of creating digital data, it's not part of the AI framework. So now let's talk about the AI framework. So the layer 1 in the Ashtang AI is what I call the interpretation layer, which is really about how do you interpret low-level data. For example, images, videos, time series, gene sequences. How do you interpret them and convert them to high-level semantics? And say, this audio is really a speech of this person. This video is an action of this type, right? So how do you convert low-level data into high-level data? Semantic form is a interpretation layer. And this is the largest layer in AI today, deep learning and everything. The next is what I call the causality layer. And really, this is about the domain knowledge and the data statistics coming together to tell us what is causing what. And this is the fundamental thing that humans do, any intelligent system does. If I give you 5 variables, the first thing you start to do is to say which ones are causes and which ones are effect. So how do we think about causality in a deep way? We will talk about that. The next is prediction layer. Once we understand this causes that, then we can actually build prediction models. And prediction models are different than interpretation models. Prediction is about looking at the past and predicting something that is going to happen. Interpretation is looking at the current data at a low level semantics, converting it to high level semantics right now. So there is a temporal gap in the prediction layer. Now, once we are able to build prediction models, it's not enough to say that I predict that this is going to happen, but you have to also explain why you are saying so, right? And that's where explanation layer comes in. And now this is an important part of a machine learning framework, that you cannot just produce a class label or a prediction. You have to also produce an explanation or a reason code along with it. Only then your model will be acceptable. So this is going to be the new norm, given all the privacy and bias and fairness conditions. Now we will switch to another dimension, which is control system thinking. So now the next layer in our framework is what I call controllability. And this is a very important turn in our way of thinking, where we say that some of the input variables are controllable and some of them are observable. And what does it mean when we make that distinction is a very important thing we will talk about. Now, once you know what is controllable, then we can build the simulation layer. And in my mind, what is how important deep learning is today, simulation will be very, very important tool for AI in the future. So today we think of AI and modeling only as building models and deploying models, but using the models to do very deep simulations is going to become an important skill set in the future. Now, once you're able to do simulations, we can start to do optimization. So what is the best pricing strategy at Ola, Uber? Uh, you cannot just come up with a machine learning model. You have to try different strategies, do simulations on the whole day, look at the revenue, and then figure out what is the best optimization, right? So we are getting into those kind of models. So once you're able to optimize, the last step is adaptation layer, which basically says, can you re-optimize again and again as situations change? So the holy grail of AI is really a completely adaptive system, complex system, which can do all this in a real-time manner. So that's the end goal. We'll achieve that across verticals, across different systems that we talked about. All right, so let's start with our layer 0. So layer 0, like I said, is a digitization layer, right? All it does is converts physical data into digital form. And we have now sensors, OCR, RFID readers, and all of that. And now we can do all of this, right? We can also think about digitization layer as, one of the great examples of this is the Google Books project, where they converted all the physical books which were printed before the digital era into a digital format so people can actually search them, right? This was a massive digitization effort as an example. So the idea is that, we think of digitization as scanning a PDF, something into PDF and storing it is not really digitization. Digitization is actually extracting all the key value pairs from that form. And this whole area of visual document processing is really about extracting, key value pairs from forms, from invoices, and all the physical printed documents, right? As a digitization layer. All right. So we understand this. It's going to remain an important layer till we become a completely digital society. All right. So now let's start with our 8 layers. So the first layer, like I said, is the interpretation layer. It's the largest layer in the AI stack. And what it really do is it basically assigns a high-level semantic to low-level data. So what that means is, so if you think about speech as a low-level data and speech to text is a high-level data, right? More semantics. Face to emotion, video to action, X-ray to anomaly. So the input is a low-level data and an output is a high-level semantics associated with that data, right? And the beauty of the interpretation layer, if you look at the human interpretation system, that we don't only interpret something in one way. If I get a speech signal in my ear, I can interpret it in all possible ways, right? What are you saying? Who is the speaker? What is the gender of the speaker? What is the age group of the speaker? What is the emotion? What is the accent? What is the background noise? What is the language? All of that, right? So we need to start thinking about not building siloed models of speech to something, speech to something, speech to something, but how do we build a common deep learning framework where speech goes in and all possible things that can be interpreted should be interpreted from that. Yeah. So that is an example of how interpretation will happen in the general artificial intelligence world. Now, what is the inspiration for this layer? Really, if you think about the human intelligence, we have a very amazing interpretation layer. We have 5 senses. Each of them is very, very sophisticated. It's a result of billions of years of evolution. And we have only mastered 2 of them, right? The ability to see and the ability to hear. But here we are yet to master or digitize the other 3 layers. And if you want to think of language as the 6th sense, then language is the other layer of interpretation, right? So we have mastered these 6 skills in the human system, and that is the first layer in the AI stack. That is the same layer in the our stack as well. So now, taking a cue from that, what I'm going to do, I'm going to show you a lot of examples of different data types, different domains, so we understand that it's a horizontal layer. So if you think about interpretation of audio, right? So the audio is interpreted in multiple ways, and one of them could be emotion recognition, right? So it's a very important problem if you want to build, therapy systems for autistic children. If you want to build a call center analysis, you want to be able to do emotion recognition on the speech, for example, right? Another example of interpretation is converting a song into these 9 beautiful dimensions. So Spotify has mastered the art of converting any audio or any music into these 9 dimensions. Again, this is a semantic interpretation of the song, and we can now say that you don't like a song really because it is by a certain musician or a singer, but you really like a song because it has a certain signature in this nine-dimensional space, and you have a certain signature of the kind of songs you will like in this nine-dimensional space. Therefore, you are going to like the next song. So see how we can use deep interpretation of content here. Text interpretation, we are a language civilization. We have so many languages across the world. And it's amazing how our brain can understand and interpret text, however weird, right? So here is an example of Apple filed a suit against Orange, and word sense disambiguation, Apple and Orange could be many things. But here our brain is interpreting and converting it to the right sense given the context, right? Filed could mean many things, suit could mean many things, but it is putting the right senses. Another example, when we actually read a lot of text, we don't store the text, we continuously extract a knowledge graph out of it. So this is what we really store in our brain, and what we read is this. So this is our information extraction is also a type of text interpretation. If I look at more text examples, if you look at Google search and retail search or song search or any kind of query based systems, the first thing they do is interpret the query. Is it a local query, is it a person query, is it a cuisine query, is it a airline ticket query, and all that. And query understanding is a type of text interpretation, right? And now we are going into question answering, so question interpretation, and then chatbots, and then utterance interpretation. So these are all examples of text interpretation. Now, embeddings is another example of interpretation. If we can now create very beautiful embeddings even at a sentence level. And here I'm showing you one sentence, and these are the similar sentences. And even if grammar is wrong, spelling is wrong, because it's all human generated content, the completely unstructured text with all this noise in it can still be converted into a nice 300 dimensional embedding. And that is also an interpretation. Converting one form of data to another semantic form is interpretation. Now we can think about deep interpretation. We don't have to do only one interpretation. So I can convert speech to text and say, hey, what is the text? What are you saying? And now imagine doing it in all languages of the world. And then understanding what are you really saying? Text to intent, right? And saying, oh, this is an intent which is book a flight, but this intent has to fill all these parameters. And how do I interpret early morning or next Monday? Or how do I know that indigo is not a color but an airline, right? So this kind of interpretation that our text to intent systems have to do, and this is the key to how Alexa, Siri, everybody works, that instead of query understanding, we are going to go to text to intent models. Another notion of deep interpretation could be deep sentiment analysis, right? So sentiment analysis is not a binary problem. Is it a positive or a negative sentiment? We can go very deep and say, which entity are we talking about? Which aspect of that entity are we talking about? And therefore, what is the sentiment on that aspect of that entity? And this we do all the time. We don't write a review of one entity only or one aspect only. We write a very complex review sometimes, right? The ambience was great, the food was spicy, and it was costly, but the service was good, right? So we can have positive and negative uh, uh, sentiment about different aspects of the same entity in the same review. And that is the deep sentiment analysis that we need to be able to do. Image is a very large data. There are many types of deep learning models for different things we are able to do now. And we can do facial expression, object detection, and in the future, we are going to be able to even detect what is the make and year and model of the car, what are the attributes of the car, what is the breed of the dog, what is the sentiment of the person, and what is the breed of the horse, for example, right? And what is the scene. So the idea is interpretation will continue to become more and more deeper and all of that, and it will become more and more multi-factor interpretation as we go along. Another example Today, the companies like Netflix and Amazon Prime, they are now saying, how do we go beyond the metadata of the content? How do we go deep content interpretation? So if you take every scene in every movie and say, you've already seen X-ray, for example, feature in Amazon Prime. So the idea is, who are the people? What is the genre of the scene, not the movie? What is the location type? What is the action type? What are the sentiments? And all of that. And now you can imagine interpreting a movie as if a AI system is watching a movie and extracting all these multiple aspects at the same time. Similarly, the fashion world is catching up on AI big time. And now imagine you like a dress, you take a photo, and then it has to interpret the image. What are the dimensions? What are the values in each dimension? And how do you map a dress into all these values, right? So this is also an interpretation of data, image data. Another very important area, emerging area of image interpretation is X-rays, MRIs, microscopic pathology images and all of that. So this is going to continue to grow. We're going to go 3D images like MRI and videos like, sonar and all of that. So this is becoming very important. Another area, we are sending satellites all the time, and remote sensing is a very important interpretation of a pixel. What is the land cover? What are the minerals inside? Is there an oil spill somewhere? Is there a good fish in some part of the ocean for our fishermen to do their fishing and all of that, right? So we can do many, many things in remote sensing world. So hopefully with a variety of examples and a variety of data types, we got a sense that interpreting low level data into high level data is a very, very important layer in AI. And a lot of people are working on how to build these models better and better. All right, so now let's move on to the next layer. I call it the causality layer. And I'm going to use this example on the left of a projectile to talk about it. So think about a projectile, you're throwing a stone from a certain height, and there are a bunch of variables involved, right? Time, maximum distance, maximum height at which you throw, angle, and velocity. So as soon as we give a bunch of variables, what happens? Our brain automatically starts to think in terms of what is a cause, what is an effect, right? And gravity is also there, wind speed is there, air resistance is there. So we start thinking about cause and effect whenever we are given a bunch of variables. Yeah. All right. So now let's talk about causality more deeply. Causality is a very beautiful area of thinking. So I'll give you some notions of causality. So sometimes there is no causality. So one of the things about causality is that sometimes things are what they are, right? So what is the gender, age, income group of a person? There is no need to worry about the causality. It is what it is, right? What is your behavior? When do you shop? When do you commute and all of that? What kind of things you prefer? All of that. What are you sensitive to? All of that. So this is all about understanding the user without wanting to know the why of it. So this is what I call the zero of causality or non-causality. All right, so let's get that out of the way. So there are a lot of variables like that. Now let's talk about different notions of causality. So the first notion I'll talk about is multi-factor causality. So when a doctor is looking at a disease, he's thinking about all possible factors at the same time, right? It could be a genetic disorder, lifestyle disorder, immunity problem. It could be transmitted to each other via COVID and like COVID. It could be an environmental issue, like, if you're living in a very polluted area, you will have lung problems. If you're nutrition deficient in some way, or something is just seasonal like dengue, right? So the idea is, in any domain, the job of a data scientist starts with listing down all possible causes of an effect. It's an important skill set that we need to develop. Yeah. Data science does not start with where is the data. It starts with what am I trying to predict and what is the causes that will lead to that. Then we go to data. Data is the last thing we go to. Yeah. Another example, let's say I'm in a telecom network and I want to predict call drops. So there, again, as a data scientist, I don't know this. I will go to a telecom expert and ask him, look, what are your pain points? So he'll say call drops are increasing. Then I'll say, tell me why call drops are increasing. What are the different factors that can cause a call drop? So he'll tell me that devices are not updated, Coverage is not there. We don't have enough cell towers. Network load may be very high during evenings and mornings. There could be too many cell towers pointing at the same phone, so the phone is getting interference. Or you are moving very fast, therefore there is a call drop. Or there is clutter, there's a lot of buildings and trees in your area, so the direct line of sight is not there, right? So unless I develop the art of writing down all possible causes of an effect, I am not a data scientist. Period. Yeah. It does not start with import TensorFlow. It starts with what are the effects of a cause. Yeah. Because that's what we are trying to predict. Now, if I take it to the next level, here we are talking about cumulative causality. So, how do we think about aggregation? Multiple causes coming together in a regression sense, right? So, if I'm doing demand forecasting, for example, in Ola Uber, I need to know that today is a holiday or not. Is the weather hot or cold or rainy? Are there any stadium events going on? Is there a commute time? Is this a commute time in the city, or am I running a campaign that the demand is high, or a competitor is running a campaign that my demand is low? Unless I can list all these factors and quantify today how much of which factor is contributing, right? Then only I can build a good demand forecasting model. Similarly, let's say I want to understand supply of cabs in a city, in a certain location, in a certain hour, or a 15-minute window. How do I think about that? So I need to be able to list all possible factors and say what are the current number of cabs, how many incoming, how many outgoing. I know from my data how many drivers will log in and log out, how many will drift in and drift out because they're not getting cabs, how many cancellations will happen from driver side, customer side. Once I list it out, the model can be very simple or very complex, it does not matter. But not knowing all the causes is a problem, right? So this is how we think in a domain-driven data science. Another kind of causality is dependence-based causality. So here, imagine you are building a curriculum personalization system where you are saying that there is a current proficiency of a student in different concepts. So student A is very good in concept P, medium in concept Q, very poor in concept R. What should he study today? Versus student B, who is very good in concept R, medium in Q, and very bad in P. What should he study today? Today we have a one size fits all, very archaic, very bad education system, and we are able to personalize your pizzas and your Netflixes and your LinkedIn's and YouTube's, but we are not personalizing the most important thing we should have personalized first, which is education, right? So this is a big pain point for human civilization, that we are not moving ahead on important areas in AI, right? So here, what can the system do? It can say, look, student A actually should be able to learn concept X because there is a high dependence between what he knows P and X, but he can also master concept Q. And let me understand, go backwards in the dependency graph and figure out why he is so bad at R, and what is the prerequisite for that. So now the system can actually propose different concepts X, Q, and something else, and say, you can study any of these. That freedom you have, but it is guided by this ability to predict what you can master, what you have not yet mastered, and what are the problems with why you are stuck. So this is dependency based, and the knowledge about what depends on what is already there. So how do we encode that knowledge? uh, Another notion of causality is temporal causality, right? So events lead to other events. So if I want to sell or send a coupon for cartridge, to whom should I send? So I can say that, look, people who buy a printer of this type are going to need a cartridge 3 months later, 1 month later, and I can think of events driving other events and the time lag between them, which is the distribution, and then I can deliver the right product to the right customer at the right time, and the time part and the product part can be personalized. Similarly, if I think about the seeds and the, in the agriculture world, which crop in which region, in which soil takes how much time to go from stage 1 to 2 to 3 is something we understand, and we can monitor and all of that. Sometimes temporal causality is just a function of, the season and not another event, right? So we need to be flexible in our way of thinking about temporal causality. Another important kind of causality is what we call structural causality. So now imagine a complex system where there are like a refinery or a human body. There are many moving parts, they are all connected to each other. And now if one of them fails, let's say this unit fails, we are going to ask two questions, right? What causes this to fail? And if this fails, what else might fail, right? So these are the two questions in a structural causality world. We always think about the same thing both as a cause and as an effect. So everything can be a cause and an effect. So let's say a liver of a person has failed. The doctor is going to ask two questions. Why has the liver failed? Is there any other organ in the body that is causing liver to fail? And he's going to ask the second question, which is, if liver is failing, what else might fail? And he's going to worry about that as well, right? So this flow of causal relationship across a known structure is structural causality. Yeah. Now, this is a very important slide, and this is the new skill set of a future data scientist, right? So imagine you are working in Ola Uber and you understand that, let's say, what are the incentives I'm giving to my drivers, what is the organic demand of cabs in a city, and what are the offers I'm giving to my customers. What does that lead to? So that leads to the supply demand ratio, right? So sometimes if I'm giving more incentives to drivers, I have more supply of cabs. And if I'm giving more offers to customer, I have more demand on top of the organic, right? So this affects supply and demand. What does supply and demand affect? It affects other variables like availability, right? Is the cab available or not? Are customers getting stock out? Means they want a cab, but there's no cab, right? Is the price going up? Because if supply is more than demand, prices will come down. If demand is more than supply, prices will go up automatically, right? So this is your dynamic pricing, for example. Is the utilization high or low? If there is too much supply of cabs in one area, drivers are sitting idle, I'm not using my resources, I'm wasting my system is not good. So is the utilization high or low? Now this is another layer of metrics. How does that lead to? What does that lead to? So that leads to other metrics like fulfillment, right? How many people actually got a cab? Conversion. At this price, how many people converted, how many canceled? What was the customer experience? Did I have to send a cab from very far or nearby? What was the efficiency of my operations? Did I actually do a good operation, or am I running an efficient operation or not? So this is what the next layer is. Now, what does this lead to? This leads to my customer and business metrics, right? So for example, is the customer engagement high? Is the average revenue per user, ARPU, is high? Is the churn high or low? Is the revenue generated is high or low? Is the cost high and low of running the operations? What does that lead to? That leads to your market share and profitability. Now, the reason why this slide is important is that a future data scientist dealing with a complex ecosystem will have to work with multiple metrics, and they will have to be able to draw this diagram and say what depends on what. And they should be able to go back and forth and say, oh, today you want high profitability. Let me figure out how to do it. Let me increase revenue and decrease cost. How do I increase revenue? I need to increase conversion and whatever, and decrease cost by improving efficiency. So you can go backward and forward in a complex system if you understand the complex system from a metrics point of view. And this is a very important role of a AI architect of the future, not a data scientist. Anybody can build a model now. 12th graders are building models now. That is not the role. The role is to understand the domain, the complexity of it, the dependencies of the metric structures, and then try to do something with that. Yeah. All right, so that was that layer. Now we'll talk about prediction layer. So here we are predicting something. Now that we understand causality, what is a causal variable, what is an effect variable, can I now quantify the causality? How much of this leads to how much of that, right? So that is where you build the a prediction model. You have a lot of input output data, and you can build all kinds of prediction models. So now I'll talk about the reasons why people build prediction models. And there are three frameworks for prediction. So let's first talk about the prediction as a way of thinking, right? So imagine there is a timeline. There are events happening in the timeline. These could be your visits to the hospital or doctor. These could be your banking transactions. These could be your Netflix transactions or retail transactions, right? So there is a timeline. You have a set of transactions happening in that timeline, and you want to predict a future event, right? So let's say you are on a particular prediction date, and you have an observation window of the last 3 months, 6 months, 1 week, whatever makes sense. You engineer a set of features, you build a prediction model, and you predict a future event which is going to happen, let's say 1 month from now, 3 months from now, right? So this is the general framework of prediction, and this is applicable in many domains, right? Now, there are three reasons why in the industry people do predictions. So the first reason is, if you are predicting a negative event like a churn of a customer, failure of a part, critical alarm, in a let's say telecom tower, or a failure of a crop, or a let's say a heart attack event in a Fitbit system. So if you are predicting something that is negative, which you want to avoid, that is the first reason we do prediction, which is to proactively intervene and prevent that from happening. So this is called proactive intervention, right? And that is one reason why we build prediction models. The second reason we build prediction models is not to intervene, but to optimize our decisions. So here what we do, here we say, I'm predicting the stock market, should I sell or buy? I'm predicting a demand, should I supply more cabs or less cabs? I'm predicting the credit risk of a person, should I give him a loan or not? So the actions that are driven through a layer of optimization on top of a layer of predictions is data science, right? And here we are optimizing. We are not here as a banker to say, hey, how can I help you improve your credit score? That is not the job of a banker. His job is to optimize his own risk and reward for each CIBIL score and say, should I give you a loan, how much, and all of that. Yeah. So this is the second reason companies build optimization models. Yeah. The third reason we build prediction models is to personalize the offering, right? So with this person like this movie or this song or this product, how do I personalize the homepage of a person? How do I personalize which ad to show or which campaigns to show? All of this is also based on prediction, right? What is the probability that this person will consume this item and when? So then I can personalize. So these are the three reasons why we build personalizations. All right, so now let's move on to the fourth layer. So now it's not enough to say that I can predict, but I should be able to say that, okay, your max height was so and distance was so and time was so and so. Is it because of the height, angle, or velocity, or gravity, or wind speed? Why did this really happen? Right? How do we explain the outcome is important, not just predict the outcome. Right? And this is going to become more and more important as we head into ethical and responsible AI. So now let's look at it from a telecom perspective. Imagine that two call drops are happening, and both of them have a high probability of call drop. And one call drop is, we have some input variables, network load, is it happening from indoor, outdoor, is the person mobile or stationary, what is the device, is there a coverage in that area, and is it interfering, right? So now call drop A happened because of one set of factors, let's say network load and device. Call B drop happened because of motion, stationary, and lack of coverage. Now, the reason these models are built is the fourth reason why we build prediction models, which is not to intervene, not to optimize, not to personalize, because we cannot do anything at the time the call is being made. But we do this only to understand cause and effect. So we cannot say that X% of the calls are dropping and they have a high probability of drop. We need to further break it down and say in this part of the city, call drops are high because of this reason. In this part of the city at this time of day, call drops are high because of this reason. They both have high probability, but the reason codes are different. This is very important because once you have the reason code, only then we can, we can sort of talk about what to do. So in this part of the city, I may have to add more towers. In this part of the city, I may have to, change the tilt of the towers, for example, right? So the actions is a function of prediction and explanation. Action is the end game in machine learning, not prediction, right? What actions should I take? And that cannot happen only if I give you a score and say call drop probability is high. You have to tell me why. That is why explanation layer is more important. So if I think of prediction, prediction is y is equal to fx, the input and output. But if I think of explanation, I will say y and e. E is explanation and y is the prediction together as a function of x. How do we get there? This is the new mindset we have to develop. Your model is not allowed to go out if it doesn't have an explanation reason code along with the outcome, right? So this doesn't happen in Kaggle because we think accuracy is everything, but we need to go beyond Kaggle and think about these things. All right, the next layer is controllability. This is very important. Now the idea is you have input variables. How do I see them as two types of input variables? If you look at the variables in purple and green, the variables in purple are actually what we call controllable variables. This I can control. And variables in green are non-controllable or only observable variables. These I can only observe, right? And this distinction is very important in our mindset when we build prediction models, right? So the idea is here, normally we think of prediction as input to output and all of that. And now we need to think of prediction as input is equal to observed plus control set of variables. And now the output is given. Now, if you can explain your output in terms of control variables, that is the key. So in terms of equations, now instead of writing y is equal to f of x, I should be able to write in the controllability world, y is equal to f of o comma c. So x you break down into two parts, and in every domain you are going to see this. Every model you will build, you're going to see some observable variables that you cannot change but measure, and some controllable variables you can actually control. Yeah, this is the controllability thinking we want to build. So for example, in the, if you're running a campaign and you're looking at conversion rate, you can say that preference of a customer is only observable. What the competitor is doing is only observable. I cannot affect that. What can I affect is what is the discount I'm giving, what is the messaging I'm using, which channel I'm using, what time is my messaging going out. That I can control, right? Similarly, in the world of telecom, I cannot ask the person to say, hey, stop the car, then make a phone call, or go to the roof of your house, apartment, and then make a phone call. So the green things are only observable. What device, is he moving or stationary? Is he indoor, outdoor? What is the network load on the tower at that time? These are only observable variables. Or what I can control is how much is the coverage in that area at that time, and how much is the interference in that area, right? So now we think about these two things. So again, controllability is the key. How do we break down our input variables into these two types? All right. So now we can now go deep, right? So now let's say I want to build a churn prediction model, and I'm saying the churn can happen because of a certain kind of customer behavior and usage, which is only observable, and a certain kind of experience I'm giving, right? Call drops and call quality and throughput. And now I'll say, what is this a function of? Is call drop a function of what? So now can I build another model that says, look at some of these variables and tell me what are the uh, uh, experience variables. And then how do I do that is another model that says, if I had a certain location and height and azimuth of cell towers and certain tilt and capacity, what would be the coverage and interference? And if those are the coverage and interference, what will be the call drop, call quality, and throughput? And if those are the call drop, call quality, and throughput, what will be the churn prediction? And I'm not even talking about the observed variables. So controllability flows through this, and that is what the next generation complex ecosystem is going to need. It's going to need an architecture of models feeding into other models. And how do we put this architecture together is the role of a new data scientist, not to build these models, right? AutoML will build it. Now, this is a very important thing. How do we think end to end? So we need to think what are the business metrics and how are they are a function of my customer experience, and how are they a function of my operational metrics, and how are they a function of my operational actions. So operational action leading to customer experience, leading to business metric is a way of thinking that we need to develop. Yeah. All right. So now we understand controllability. Now we'll talk about simulation. Simulation is a very important layer, as I talked about earlier, in the future. So here the idea is we have built a very accurate prediction model, but now imagine you have a slider and says, how much discount should I give and what is the effect will that have on a conversion rate for a given preference and competitor, and other control variables being constant. So now you can play with this controllability space, which is a subspace of the entire space, and say what happens if I do this, what happens if I do this combination, right? And as the dimensionality of control variables grow, the complexity of simulation systems grow, right? And we can do this in every area and say, if I increase the coverage, will the call drop come down? Therefore, I should put more cell towers in this area, right? That kind of thing. So now controllability is really about predicting this to that, but simulation is about trying different control variables for the same observed variables and saying what would be the outcome yi. So I is a very you're trying many control combinations and generating a lot of data and seeing what are the outcomes if you do this, if you do that, right? So this is a simulation thinking applied to these complex systems. And now I can do a deep simulation. I can go from, if I change the tilt here, how will it affect coverage and interference? And if they get changed, how will it affect call drop? And if that gets changed, how does a churn change, right? So how do we think end to end in a simulation framework? And because everything is a result of a previous thing, we talked about causality, and ultimately it all boils down to operational actions. And really the end goal is to simulate your operational actions to handle business metrics. And because it's a complex system, there is no simple way to do it. You have to build individual models, cascade them together, and then you have to start simulating. Now comes the optimization layer. And here I want to ask a different question. I don't want to predict. I want to optimize. I want to say, hey, I want to maximize the distance that the projectile will go to. What should I do? What should be my control variables if these are my output variables that I want? So it's a reverse problem. Yeah. So optimization layer really is, if you think about simulation, what did we do? We did this. Now we are going to do optimization. Optimization is a reverse problem. The model is the same, but now we are saying, the question we are asking is, what combination of control variables should I apply for a particular customer in a particular competitive scenario so that my conversion rate is maximized? So now I'm solving an inverse problem. That's why the arrows are backward. And the way I write it in the function world is, I'm saying give me the best control variables so that for a given x, I get a desired y. So y is a desired y, maximize conversion, and x is a observable, and what should be my optimal control variable. So that is your really optimization job. And this is when we finish our work as a data scientist. We don't finish it because we have built a high accuracy prediction model. So how does it work? So now I can say, hey, minimize churn. How does that flow backward across the city? Then we'll say, okay, reduce call drops, increase call quality, increase throughput. How does that flow backward? Then it tells me that this is where coverage has to be increased. This is where interference has to be decreased. Then it goes backwards and say, this is where the tilt has to be changed. This is where the capacity has to be added. So you see, optimization leads to operations action at the ground in a very complex system, right? This ability to connect all of these layers and build a system like this, which can really think in a complex way, yeah, is our goal. The last layer is adaptation layer. So the idea here is, let's say we go to the moon or Mars where gravity is different. Earlier, gravity was an observed variable. Now gravity itself has changed. So now all my equations will have to change and I'll have to adapt. How do I do my projectile, right? So adaptation is really about re-optimization. So the idea is you have a conversion rate, you have done this optimization once, but now what happens? Let's say the person got married and he has a different preferences, right? So the preferences have changed or the competitor strategy has changed. So when the observed variable has changed, then you have to re-optimize your control variables, right? So the idea is this ability to re-optimize when the observed variables are changing is adaptation. So it's a layer on top of adaptation layer. So controllability is F of O and C. Simulation is different for different C's. Can you generate different Y's? Optimization is for a given observed and a desired Y. Can you give me the optimal C? And adaptation is, can you keep doing it again and again, right? So Y is the same. I want to still maximize conversion rate, but my observed variables have changed now. So O is a function of time. Therefore, control variable is also for optimal control is a function of time. So that is adaptation. So you can imagine this happening in a city, for example. Now I can say that, let's say I have more cell towers in different parts of the city. Network load has changed from morning to evening. Loads are different in different parts of city. The usage of customers have changed. So the green variables have started to change. What do? I re-optimize the whole thing and come back and solve that problem. Yeah. So let me close now. So these are the 8 layers. Hopefully you got a sense of how much of AI we don't do today. So this is what we need to do to build our complex systems. And hopefully this has added a new perspective of how you think about AI, and especially these layers of controllability, simulation, optimization, and adaptation will become more and more important as we have perfected the art of building interpretation and prediction models. Causality thinking we will have to develop, and explanation and explainability is now an emerging area. We need to master that. Then we will put together the entire system. Yeah. So thank you all for your time. It was a pleasure talking to you. Thank you.
Thank you, Dr. Shailesh, for your insights. Hey, you know what? Recently, I was reading about this incident from Amazon where their recruitment algorithm based on AI favored male candidates over female, thereby giving the former an upper hand.
Right. Thankfully, they shut it down in 2017.
AI model is only as good as the data that is fed into it. So if the data has a human origin, the model will mirror it. Similarly, if the data is biased, the outcomes will also be biased. We will hear all about this in the next talk from Juan and Rishikesh. Let me give you a quick introduction about our guests. Juan is the head and subject matter expert in data science in AI from Globant. Rishikesh is the data science community lead and the tech manager from Globant India team.
Okay, so welcome to this session about explainable AI and what we mean by that, and trying to explore a little bit of what it is, why we should look for that, and what we mean when we're talking about bias and trust and increasing that. So the agenda for today, first of all, is should we trust AI at all? Then we'll talk on the difference between explainability versus causality, whether AI can be unbiased at all or not, and how we tackle that. How we bring this all together. I mean, how do these all parts fit together? If we go into the practical sense, what kind of packages can I use when I'm trying to code or build this AI? Some examples, some concrete examples about how do we see these aspects working, and some recommendations of our own and our experience. So the first thing is, should we trust AI? And trust is a contentious word, let's say, because are we talking about trust in the sense of, like, when we're talking about currency, like a reserve of value or something that we all agree works in the same way? Or are we talking about trust in the sense of safety and being safe, or that it will not have unintended consequences? So it's not necessarily clear what we talk when we talk about trust. It's an open debate, and so we have to break that up a little bit and go into more of the details. So, for instance, when we're talking about trust, terms like transparency and fairness come to mind, and though they are usually expressed together, when we're talking about transparency, we're talking more about having a view of how decisions are made versus fairness, which is an evaluation of whether we believe the decisions are fair and are correct and are applying what we believe is to be fair. Another concept related to trust has to do with accountability. Do we know who made a decision or how a decision was made? Do we know who is responsible? And by who, I mean person or machine. Do we know how that came to be constructed? Another aspect of trust has to do with privacy, which is this algorithm, is this data process respecting my privacy, is respecting data that it shouldn't be accessing or not. And it might have not to do with the outcome. Maybe I even like the outcome, but the problem is that if it's using data that it shouldn't be using, then I might not trust it. Another aspect, for instance, has to do with the confidence, which means, in a sense, if an algorithm is saying that this is the correct outcome, how likely is that to be true? Do I trust in that evaluation? Or on the flip side from that is, this algorithm may work very well for some use cases. Does it generalize enough? Do I believe that it has learned or it has memorized something and it's just repeating that? And then, do we have humans in the loop? And this is something, for instance, when we're referring to things like health or in contact with children or vulnerable populations, is there somebody that might take on the reins if things fall off the tracks? Does the system have those things in place? So maybe trusting the system. So in the end, when we're talking about trust, we're talking about a lot of concepts, like this idea of equalized odds as a treatment for biases, whether groups are treated fairly, whether there are statistical conditions about the results that we can apply to the model or that we can guarantee from its results. And I would say it's a big word salad. There's a lot of concepts related to this, and the way people talk about trust usually has a lot of these intertwined elements taken at the same time. So we have to kind of focus on what happens when we don't trust AI, for instance. And one of the main things that we see is lawsuits. So, for instance, the problem about using an algorithm for reassessing values for tax that might be perceived by the taxpayers as unfair and unconstitutional, and actually they win the lawsuit because there was this issue of lacks of human review. Nobody was kind of in charge. How the change happened was not transparent. The performance was not up to par. And so if we don't trust AI, there is lawsuits. Or this other one about whether a system to assess the severity or the how dangerous a person might be regarding the past offenses and things like that, whether it can be used or not, because there was a fear that it was biased against race or against other things and didn't want to create a precedent. And so the problem is that the injunction, the lawsuit was won because it was merited that there wasn't enough sufficient research about the impact that this system had. There were concerns about the socioeconomic bias, miscalculations, and things like that. Or the case where this algorithm was used to rate how much value a teacher was adding to school in Texas, when the problem is that, well, it was not really clear to the teachers what factors were being considered. And so if you're using that bar to measure them and they don't know exactly what they're measured on, that it's hard to say that they can trust. And so the lawsuit was won in terms of accountability or the capacity to be transparent or to have the trade secrets and how you're applying to populations. So if we don't trust AI, if we can't trust AI, the result is that we're going to be having lawsuits. And this is why it's important that we deal with this issue. Now, one of the ways that has been touted as a way to increase trust in AI has to do with, well, if I can explain it, if there's a causal model, then I might be able to trust it. But there are some concepts that we need to take into account when talking this way, because, for instance, the idea of interpretability, which has to do with this degree in which the humans can have a sense of why something is happening, is some people talk about explainability in terms of that. If I can interpret the result, then I have explained that. And that might be important. That might not be possible depending on the situation. Another term that gets thrown out there within the mix is the idea of explainability. And what we mean in this sense by explainability has to do with this understanding of the internal logic of a system. So whether I can follow the mathematical formulation, whether I can tell why a given decision was made, whether I can follow from the initial input to the output and things like that. And let's say the highest form of explainability or interpretability, we usually attach to this idea of causality, which means that we know of the mechanisms by which a given result was produced, and we understand the reason. Now, this is very powerful because it enables something like the counterfactual analysis, which means that I can test whether the elements that the model is using to come up to a conclusion actually are relevant and can take the test of time. And that leads to actionable insights, because if I know what factors, what are the levers that are actually pushing for a given solution, that tells me what do I need to act upon. So let's say that I'm using something to assess the risk of a default on a payment, and I know the factors, I know what I have to change to actually improve my odds or improve the results from that model. Now, these three elements are somewhat more or less present in different types of models, in different types of modeling techniques. And we have, for instance, the whole family that we can group within the transparent machine learning models. And we mean transparent in the sense that we know exactly the calculations that are being made so that we get to a result. If we see a linear regression, we know what was the weight, we know what was the input, and we know what was the impact on the outcome variable. If we have a decision tree, we can trace out the whole logic of how a given classification was made. If we have a Bayesian model, we know the probability of the conditional posterior probability given the inputs that we have and things like that. And so we can see the mechanism of the model. Now, if we understand why a given factor was considered before the other, that's another discussion, and that has to do with this idea of whether the causality and the explainability can be followed upon. But at least we can interpret that because we can see within the model. Now, there are other models which are harder to see, more akin to black box models. Well, the kind of explainability we can have is what is called post hoc, which means that we will build something on top of the model to try to pick or to explain what has happened within that. That's this, for instance, with neural networks happens a lot, because following the exact calculations to get to an output might be untraceable. But we build these models to say, well, but these were the inputs that had the most impact, and these are the ones that aren't as relevant. But we're building an explanation after the fact, and we have to be very careful with that. And what this means is that we always have to deal with this kind of trade-off, which is on one side, if the model has more accuracy, it is more likely to be harder to interpret that. And the relationship comes from this idea that more complex models have more, let's say, it's not techniques, but have more power within themselves to adapt to reality and situations, and hence we lose that capacity to see why something has happened. And together with that, with the growing model complexity, usually we have less trust, because we cannot see, we cannot interpret, we cannot explain, and so we might get a very good performance, but we get further away from this idea of, okay, you might be right, but I don't trust you. And now, how do we actually solve that? Do we attack that problem? And one of the main issues for trust is about the bias. And the question that we always will have is, can AI be unbiased at all? And so when we're talking about bias in this case, is this as a way of formally defining that, which is always an issue, because bias is used in the context of the kind of the natural language and also in the technical sense at the same time. But we're talking about this systematic distortion in the data that compromises how representative it is. And it's one of the things that worry the most to people about the use of AI, like whether the models that have been trained have these biases within them that will replicate, whether there are groups that will be affected by that in a disproportionate manner. And so the whole idea that AI can be biased is one of the drivers of people not trusting AI. The bad news is that we have to live with bias. There are different types of bias. So, for instance, we have what we call the pre-trained bias, which is what stems from imbalanced data sets, because we only have data for one population and not the other. Selection bias, because the data we might have used may have gone through a process and we don't know about other things. So, for instance, the typical case of the survivorship bias, where I only know about the cases that were successful, and so I may attach a given behavior to characteristics that are actually normal in any case that also failed. Sampling bias, which has to do with the techniques we have used to actually go through the data set, and other types of systemic errors. Now, how do we deal with this? For instance, there are algorithms like the repair algorithm that is used to handle or deal with things like race, gender, ethnicity, and things like that. There are algorithms about balancing the data sets that may introduce other bias on their own. There is a more sophisticated sampling technique so that within each group, even if a group is of a smaller size regarding the whole population, we will still have enough representation to understand internal dynamics. And then there are bias metrics that we have to be careful because some data transformation, for instance, like PCA for simplifying the data sets may introduce bias on their own. And then we have the post-training bias, which is the bias we attribute to the model itself, not to the situation we train on. Um, and there are different types of bias. This is not expected to be like the full list because we will discover more as time progresses as well. But some of them that we need to take into account have to do with the algorithmic bias itself on how the algorithm we have chosen, the loss function, the way we train that induces for a given result, like when we're looking for on a given performance of the algorithms, the recall, for instance, of the algorithms and things like that. Things like what is called the hot hand fallacy on the Van Wagon effect, because maybe we have trained a model and it's the only one we have, and that's the only one we use, but we don't know if it's actually better or more balanced than another alternative, or not using a model at all. Or the Van Wagon effect, which is like, oh yeah, let's use these huge language models because it's what the big companies are doing, and they might have these inherent language biases about the given groups. Group attribution bias, which has to do with a lot of the kind of correlations that we have within the data, and misattribution of behaviors and outcomes to variables that might be just confounding variables. Aggregation bias, things like Simpson paradox, and evaluation bias, which is by the way we measure, we're tainting the results and we're tainting the way that a model is trained on. So the way to deal with that, or the way to approach this, has to do with considering the context and understanding what are the factors that we should be considering when making a decision, and whether that is reflected in the model or the model is leveraging a proxy that might be hurtful, by trying to, for instance, eliminate highly correlated features so that we avoid these confounding variables. Because, for instance, in the US, you may not use race as a variable for a model, but you may use the zip code. And given the social structure of the land, that zip code is a proxy for race. And so you will find that those two are very highly correlated. You should eliminate those before training the model if you cannot use one variable. Otherwise, you are just using the same variable with another name and another number in the same model. Something that is useful as well is evaluating multiple models, because given the internal structures and the way they learn from data, they might learn different sets of biases or different, let's say, preferences, and balancing that out can help in having a more comprehensive picture. Avoid stereotyping, which is very important from the design and the framing aspect, and considering which variables and which decisions we're actually making. And also this idea that different subgroups may need independent models because they might have different characteristics. We will see this a lot in health, for instance, trained models, where given the different populations do have different risk factors, and if we just aggregate everything within one model, then maybe other factors will, some very important factors will not be taken into account, because on the majority population, they might not play a role, but on the specific population, they are critical. And so we need to think about that when we're framing the model. Once it is trained, it's harder to deal with that bias, but before the training, we need to consider this aspect so that we don't build so much post-training bias. Now, we'll go through an example. Hrishikesh here is going to lead you to how we can actually see this in practice, because I may be describing some of the terms, but once you see this in the specific numbers and specific results, it will be much clearer. So, Hrishi, up to you.
Thanks, JJ. Thanks a lot for this. So for the example, we'll start with the COMPASS dataset, the infamous dataset, which really predicts whether a person, an offender really, is at the risk of violence, at the risk of recidivism, that is repeating the violence, or at the risk of appearing to failure. And this dataset really considers race as one of the primary features, so there's potential that the data set is biased based on the number of people you have. And we'll see those in the examples. So here, what we have done is we have used a tool called SageMaker Clarify to really detect pre-training bias that JJ was talking about. So it provides a very nice UI along with it. So in the example that you can see, what we have done is we have tried to get the data for a pre-training bias for a particular race, in this case Hispanic, and for the people who are at the risk of violence. And if you see the class imbalance, it is 0.82, which essentially suggests that the model will learn that the Hispanic race are more prone to violence. Okay, which is incorrect. What this tool also gives you, it gives you a chevron on the right hand side, which you can expand. So each metric, the details of each metric are given, how to interpret the metric, what the metric means. If you want to know more, where to seek the information about it. So SageMaker Clarify is one of the very handy tools for detecting the pre-training bias. Um, there is one more tool called Google What If tool, and what we have done here is we have integrated with another tool called SHAP, okay, which is used for explainability. So one of the examples that I want to give you here is that of counterfactual. So JJ talked about counterfactual analysis earlier. So we can see a couple of data points here where the only difference which is there is between the age of two people. The person on the left is 32 years old, whereas the person on the right is 31 years old. And we can see from the predictions that for the person who is 32 years old, the risk of violence is nearly 34%, whereas it shoots up with the decrease in only 1 year for the person with 31 years old to approximately 95.4%. It clearly shows that the algorithm has learned something which has really caused this effect, and it is something that is not really explainable. Okay, one more example on race-based bias. Okay, so this is a data point where the person represents a Caucasian group, where the number four represents Caucasian, and the attribute value is approximately 10%. If I replace this, so Google What If tool gives me the ability to replace this some of the values to see what happens if I replace these values. So what I've done is I've replaced it to the value of 1, which represents an African American person. So what we can see here is the risk of violence in this case increases from 49% previously to almost 59%, a 10% increase just on the basis of race. Again, shows that there is bias present in the data. And if I train a model, the algorithm has learned about the bias and giving the probability on that factor. Okay, so how does it really all fit in, so what we do is whenever we are training a machine learning algorithm, or really creating a model for one of our use cases, is we first ingest the data, do the data exploration, do the EDA and transformation, followed by choosing the right model, training the model, training the hyperparameters to optimize the model, and then evaluate the model for the best fit. And once we deploy, we start monitoring the model. So essentially, at a large scale, this is what we do as of today without explainability. But if explainability comes in, what will happen? We'll just see this. So first of all, once we get the data, we need to measure the fairness and bias that is present in data, and we need to attempt to reduce the bias. Now, reducing the bias is no easy task, but we need to try and do that, and not only attempt to reduce the bias on data ingestion, but even after data transformation. So some of the points that we will consider is the first one would be the basic point where we eliminate sensitive features like race, religion, so on and so forth. Another one would be the same example that JJ gave, that your race is essentially very, very highly correlated to your zip code. So eliminating the race may not be sufficient. You may have to also eliminate the zip code. So we have to essentially eliminate the highly correlated features with these sensitive features, and then check for bias matrix before and after transformations. So transformations like PCA or SMOD, they can introduce bias in your data set. And finally, we need to ensure that there is randomness in data, and we, we need to ensure that the sample represents the population. Okay, so once we have reduced the bias in the data as much as possible, we move to model training, where we need to see whether there are biases in the algorithm that we have chosen and attempt to reduce that. And that is not enough. We also need to really try and explain the models. And what do we need to do for that? So we will have to explain the models at a group level, at a subgroup level, try and give global explanations as well as local explanations. That really is the basics of it. Then we'll have to um, evaluate multiple types of models, where JJ spoke about the bandwagon effect earlier. So we will have to see which model best fits our use case. We'll have to check for counterfactuals, like the example that we saw in case of age, where the age was just apart from 1 year and the probability just shot up from 49% to 95%. And finally, we'll have to monitor the model drift and bias once the model is deployed in production. The most meaningful thing that you can do after all of this is probably provide actionable insights so that we can reduce the bias in the data set. So as you can see here, um, adding explainability to your models is no small feat. You'll have to add a whole lot of effort, a whole lot of timeline as well, to build your models, to make your models accountable and explainable. So what how can I do that? So we saw two packages already, but what are the other tools in the market that are available? At the very basic, there are these packages of facets overview and facets dive, which give you a neat representation of the data. It allows you to play around with the data, and you can visually see if the data is biased or not. Then we have Amazon SageMaker Clarify, the example of which we already saw. But one of the very good tools that is present is SHAP, where it explains the model, um, uh, the model data. So it explains the data irrespective of the model. So it is model agnostic, and so is Lime. So these two packages are very, very frequently used in the industry to try and explain the models. But then there's a very good tool called Google What If tool that not only help you explain what is going on, but it also helps you generate counterfactuals. It helps you to analyze multiple scenarios or what if scenarios. So like we saw when we changed the race from Caucasian to African American, we saw what would happen with that model in terms of prediction. And when it comes to deep learning model, DeepLift is one of the open source which is available. But the best tool there, in my opinion, is the language interpretability tool. And we'll see the demo of that in just a bit. But there's also one more package called AI Fairness 360, which is provided by IBM. So essentially, if you want to explain your model, if you want to explain your data, you may have to use one or more tools out of this. Using or sticking to one tool may not be sufficient. It also depends on the context where you want to use your algorithm. So let's see an example of using a no-code, low-code solution of language interpretability tool. So I'll just go with full screen mode here. So language interpretability tool is one of the open source platform provided by Google, and you can view this tool at this particular URL that you can see in the browser. One of the best features that these tools supports is it gives salience maps, which means you can use it for computer vision kind of models. So CNNs basically. Then it gives attention visualizations. That means you can use it for complex NLP models like those of transformers. Among other things, it gives matrix calculations, the counterfactual generation, prediction, so on and so forth. Plus, it supports multiple tasks that we do in machine learning. And lastly, it is framework agnostic. So irrespective of the framework you're using, you can always use this tool. So there are some very cool demos that are provided here, and you can run it on image classification or on tabular data or on NLP. So let's see an example for tabular data. Here we are classifying the penguins based on multiple characteristics like sex, island, flipper length, column length, so on and so forth. You know, and one of the cool features that is visible outright is that this particular tool helps you to generate counterfactuals. So if you see the one of the example, the selected one has the island of Dream, whereas the island here for counterfactual is Biscoy, and you see the prediction has changed. It really shows that the effect that one particular feature can have on your prediction. Plus, it also explains in terms of probability. It also helps you to evaluate using different metrics. So in this case, the model is not very good. If you see the uh, if you see the confusion matrix, but then the tool provides all kinds of visualizations that you want here. Not only that, you can compare your data point with the entire data set, so on and so forth. So there are multiple capabilities that are provided within this one. Okay, so let's see an example of computer vision. So this particular example that I've selected is that of a parachute, where you have a salience map generated for grad algorithm, and you can see that the probability is close to 95%. And if you see closely here, the pink dots are really the salience points here, which suggests that the object detection is based on the um, edge detection algorithm here, and that is why it's able to predict a parachute with such a high accuracy. So what this tool also does is it allows you to compare different data points. So I'll have to switch on the compare data points on. So what I've done is I just switched on the compare data points and selected another data point, which is a parachute. Okay, so in this case, again, I've generated the salience map, and you can see that this particular image is smaller. So the edge detection algorithm is slightly confused by the clouds that are there here, but then it still detects a parachute with a lower probability though, close to 38.9%. All right, so this was an example of computer vision. Lastly, let us look at an example of NLP where we have the movie review data set. Okay, so it gives us some really cool features here. So we can see that the review is there and the prediction is there. So the first point which is there, the predicted label is incorrect, but only by a margin of 0.05, or by a margin of 0.5%. Okay, so on the left hand side, you can also see a map. So the visualization is using a UMAP transformation, or you can also go for a PCA transformation. And based on this visualization, you can select what kind of transformation you want to use. So in this case, what we will do is we will enter a custom input. So let's say for multiverse of madness, I will enter the review. Just give me a second. Okay, so the review that is entered is like a multiverse of madness felt more like a horror movie rather than a superhero fiction, and maybe it was too much for a Marvel fan. So when I requested for the prediction, okay, you can see here that it has predicted a negative review label with a 67% probability. And so if I add a positive sentence at the end of it, okay, I can still see the change, so this should really reduce the probability, but still it is a kind of a negative review um, that will come out. So what this language interpretability tool also allows me is allows me to explain the model based on this data point. So if I go on the explanations tab, we can see that the probability of each of the words is explained here in the grad 2 and grad input um, algorithms that we have used here. And one of the important thing to realize here is the words however. It really shouldn't have mattered in the review, because I would expect that whenever a review is like predicted, it would take only the words that matter instead of words like conjunctions, or normally this would be a stop word. So if I change however to say and, okay, so let's see what happens. I would expect that this particular review will reduce the probability of being a negative review, okay, based on the explanation that I just saw. Okay, so once we have done that, um, just give it a second more. Yeah, we can see that the storyline becomes the most prominent word, and the review has turned to a positive review with a 60% confidence. So this is a very good demo of language interpretability tool, and the way you can use this tool. This is not a completely no code tool. You'll have some bit of code, so it's essentially a no code tool, and you'll learn more about low code no code solutions in data and AI space in the next session, which will be taken by Ghazal and Vaibhav. However, to conclude our session here, uh, the recommendations from this session that we take away is that the transparency is the key, and we will have to check for global as well as local explanation, look out for groups, subgroups, and ensure that we are not introducing bias anywhere. We'll have to check for bias at each step, like um, uh, after before data ingestion, sorry, after data ingestion, before data transformation, after data transformation, before and after model training. Okay, and finally, we'll have to include XAI in the development lifecycle. As you know, some of the countries have already started to make this mandatory if you are going to use these algorithms in production in critical use cases. So essentially, XAI will help you go from the killer terminator to the savior. So we do not need to view AI as the killer one, but we can work with it and help us build a better future. So that's it from us today. Thank you.
Thank you, Juan and Rishi, for your insights.
All of this sounds cool, but don't you think it will take a lot to implement such solutions? The prerequisite list and learning curve will be huge.
Don't worry, we got you covered there. Ghazal and Vaibhav will be talking about the approach which requires little to no coding when it comes to building such solutions. So Ghazal is a software designer with data and AI studio from Globant India team. Vaibhav is a seasoned data architect at Globant.
Hello everyone, and welcome to this next session of the DNX 2022. Like we discussed in our previous session of XAI, the day in and day out we are looking out for innovations, for new practices, growing each day with simplified workflows, with hyper automations, gaining extra profits with limited resources. We're looking out for increased agility at the same time striving for, you can say, accurate proficiency. Having all of this under a single umbrella in a very short span of time, is it really possible? Well, certainly it is with this fast evolving methodology called the low code, no code platforms. So, yeah, we are in this session are going to talk about how low code and no code is digitally transforming the IT industry today. So, without taking much of your time, let me quickly walk you through the agenda for today's session. So first of all, I shall explain to you the anatomy behind this methodology, how we are using this methodology in our day-to-day life. And then we shall technically speak about what is low code, no code, its salient features, how do they, make this methodology stand differently into the IT industry today. Followed by that, we shall look at the historical evolution of this approach. So the questions like, has this methodology or approach altogether a new one, or is it something that has been evolving over the period of time? Followed by that, my co-speaker Weber will, with an example, explain to you the scenario of how low-code, no-code development is actually fitting into our industry when it comes to the data perspective. Then we shall look at the deciding factors and know if uh, how do we select upon whether to go in for the low code no code platform, or should we continue with the traditional approach, because not always can we opt in for this approach, right? We should look at the pros and cons associated with this approach, and also maybe I shall quote a few facts about this approach. And finally, the key takeaways from this session we shall mention here. So, quickly getting started with the anatomy behind this approach. So, looking at the figure on the slide, you can very well imagine what am I going to speak about, right? So the talking about, you can say that the greatest ever machine that is known to us is the human brain, right? So it is designed in a way to handle complex situations, to store massive amount of data, process this data seamlessly to derive informational insights, to take decisions, etc. But if you keenly observe, our brain also works in two modes. One is where it processes the information faster, intuitively, or we can call it more often as subconsciously. And the system two, or the mode two, which I can put it across as, which takes extra efforts to consciously understand the situation, read the surroundings, understand it, and then react accordingly. So this is considerably slower when compared to the system one, right? So let me elaborate and make you understand what I'm actually talking about. Yeah. So like I said, in the system one, which processes the information faster and intuitively, what it means is it basically works upon the patterns which are already developed and are practiced upon right since our birth. Like, say, for example, a child first crawls, right? And then it walks, and then it runs. There's no child who at once is going to begin running, correct? So over the period of time, our brain and muscles coordinate to read this pattern, evolve over time, and from crawling to running, and from crawling to walking and then to running. So therefore, this task is basically moving from system 2 to system 1. So system 2 here is kind of responsible for all the initial efforts that the brain takes to read the situation. It takes the efforts to train the muscles to adapt to this new development, and then entirely uh, creating a new pattern where it's going to coordinate or have the coordination between the brain and the muscles through the neural pathway, and then store this particular pattern somewhere so that the system one is going to make use of it, right? So here you can see that the child first initially is crawling, and then it is trying to walk, and then it's going to run. So having said that, the analogy is quite straightforward, where the traditional or the high level programming that already exists into our IT industry is working on the principles of system 2 of our brain, whereas the low code, no code practice is more of like the system 1 kicking in as the new patterns which are identified, solved, and which can be practiced upon, right? So I'm trying to make an analogy here, like how the low code, no code platform, along with the traditional approach, is trying to fit into the IT industry, right? So this is an anatomy, you can say, because we are trying to relate to the day-to-day lifestyle that a person, is taking up from our birth, uh, where our brain, that is the machine here, is trying to control it. So having understood the basic anatomy behind this approach or this methodology, let us get into the technical side of it. So, what is this low code, no code all about? Yeah. So, if I'm to define it in more technical way, this is an approach to software development where building applications, designing solutions, creating data models or strategies uh, are all related processes, right? Which involve very less or no coding involved into it. So it is a platform, you can say, which relies more on drag and drop functionalities along with, some simple logic driven visual interfaces, uh, which would exclude a lot of, traditional development practices of uh, building up into, like the high level language coding. And again, I would put very interesting point here that the intuitive tools which these platforms are equipped with, the users with no formal training or maybe um, who are not very well trained with the coding practices can also make use of this platform when it comes to creating the solutions. So owing to ease of use and these simple functionalities, the low-code approach is gaining momentum here, or it's becoming a more preferred alternative to the traditional methodologies. Now, like say for instance, earlier, just to have a proof of concept, we would like maybe take weeks together, or maybe a couple of weeks, in order to um, in order to have these POCs develop. But at the same time, now if low code, no code platform is being used, then an SME, for instance, can use this particular development platform with small little training data. He can have this POC created maybe in a couple of days instead of weeks, and have the POC ready to get the acceptance, right? So here on the screen now, if you see, there is a kind of graph that is plotted with x-axis ranging from non-programmers on the left-hand side to the programmers on the right-hand side. And on the y-axis, we have simple use cases to the complex use cases. So currently, if you see it, the low-code platforms are all associated or are all seated into the third quadrant with having the automations and the workflows being simplified. So here we can see that simple use cases along with non-programmers with this particular approach, things are attainable. So when gradually the complexity increases, we would require certainly the technical experts to pitch in, and that's how this approach or this methodology is going to evolve over time. Because currently it is into its budding state, is what I can say here. So having said all of this, I would say all of this boils down to the augmented ability to automate the process, quickly meet changing demands, and accelerate the digital transformation, which perfectly aligns to the quest of agility these days, especially after the COVID-19 pandemic, I would say. So, looking at this as a holistic view about what low code, no code is all about, let us quickly see what are those features which are making this low code or no code platforms stand differently, right? So, these are a few features which talk about um, you can say like which are in a process of making this more agile or user friendly and scalable, you can say. So quickly let us run down each of these are actually quite self-explanatory, but these are all interrelated again. Now, like I mentioned, um, this platform or this approach is more of with the drag drop interface, having all the components which are already built, so we can make a reusable components out of it. So it's reusable, you can say. The visual modeling tools, like I mentioned, the simple logic driven visual interfaces which are there available, right? So we are just going to drag drop these components or these visual tools on our canvas, or maybe to develop our application, or to design any data strategy or any data model. Similarly, this needs to be scalable as well, definitely, because a solution just cannot confine itself or saying, okay, this is the end of it. It needs to be evolving. The reason is today we are looking out for innovation. So definitely day in and day out, we are looking out for scalable solutions. So along with scalability, definitely there comes an urge of cross-platform accessibility as well. So we cannot confine saying, okay, it's only going to work on this operating system, or only it's going to be working on, say, the systems, that is, I mean, the laptops only or the desktops only. It needs to be multi-device and, cross-platform. In short, it needs to be a robust. So is it with the low-code platform. Then we have definitely security as another important feature here, because without having those protocols, no solution is going to be acceptable. Definitely, how much ever user friendly the interface is, or how much at ease the platform is, but if there is no security, certainly people would discard it, right? So security here, there are already implemented, you can say, protocols in order to avoid the loopholes. The performance management is done using the life cycle management and the other reporting and managing tools. So with all of this, I would say it kind of states that certainly these salient features are like the backbone for the low code development platforms. So having said this, is low code something that has evolved over the period of time, or is it something new? Well, low code platform may be new, low code no code platforms may be new, but the idea behind this has been evolving over the period of time, you can say, right, since decades. Why I say this is because if at all you consider the initially or at the very initial stage, we have the machine code. We used to deal with just zeros and ones, correct? So it was really very difficult for us back then to understand the zeros and ones. And so, to ease that thing up, we got the low level programming, that is the assembly language. The mnemonic code was developed for certain operations, and with this ideology, it was like, okay, we are trying to invent this low level programming to ease up our efforts with the machine code. Over the period of time, this was also a tedious task because it was not human understandable again. So we came up with the innovation or the introduction of the high level programming. Like we had Fortran, we had COBOL, we had C, C++, Java, Python, Ruby, etc. There were a number of languages that were developed, right? So this marked as, you can say, a renaissance period for the IT industry then. So, and these languages, they literally ruled over the industry for years, with a number of upgrades that happened. With the strong scripting languages were introduced, there were different features that came up. So this high level programming languages that we had, so these ruled the industry, and certainly had a revolution during that period. Then, somewhere around in 2005, 2007, came the era of mobile computing, where the industry gained popularity with the iOS development, with the Android development, and then after came the era of mobile computing. The mobile platforms emerged. This again was altogether a new era of development. And post that, somewhere around, I think in 2015-16, or the drag drop functionalities, the rapid application development that we call as RAD and all. So that got developed. Platform as a service, the cloud computing, that made a remarkable achievement, right? And now post the pandemic roundabout in 2020, so there increased the craze or the need of digitization. The businesses had to maintain, the balance between the supply and the demand. We had to upgrade our standards and maintain efficiency at the same time. That's where the low code, no code gained high popularity. So I would suggest, so as per me, this low code, no code may be new, but the idea of easing up things, getting or raising the bars of efficiency, this is the idea behind this particular approach. So I for me, the historical evolution behind low code no code has started, like you can say, decades ago. So currently, since like I said, that the low code no code is gaining high popularity, you can say we can see a foreseeable future. I mean, it's gaining momentum day in and day out. So yeah, having given you about the brief anatomy, technically telling you what low code, no code is all about, giving you the historical background of this approach, I think it is time for us to, take a, a step ahead and maybe understand with an example how this low code, no code is fitting into our industry. So I would request Vaibhav, my co-speaker, to please take over and make our audience understand how this particular approach is fitting into our industry when it comes to the data perspective, when it comes to the development perspective. How can this be with ease of use, like the salient features which I mentioned, you will be very easily able to relate here when Vaibhav is going to explain to you how a pipeline or how a solution in minutes or in hours can be created. So over to you, Vaibhav.
Thanks, Gazelle. Good evening, everyone. Welcome to DNX 2022. So far, we have seen introduction about low code, no code, anatomy behind it, and historical evolution. Now, let's take a look at the scenario, the business problem, or the use cases that we face on day-to-day basis into a data space. So let's say you want to create a Spark workflow to ingest the data from different source system, for example, third party, and then you want to perform some transformation or aggregation, and then you want to load this data into a target table, which can be consumed by downstream applications, for example, Power BI, Tableau, or any other downstream application. So consider we have two separate entities called as customers and orders. Now we want to ingest these two entities from the Databricks file system, after which we want to perform the transformation, for example, joining or cleaning, or maybe we want to concatenate first name and last name, and we want to get the full name of a customer. And then we also want to perform the aggregations. For example, we want to find the total purchase that customer has made. We want to find the total number of orders that customer has placed. And then we want to load this data again back to Databricks file system or any other target table. Uh, with the help of low-code platform, this requirement can be achieved, and we can create a Spark workflow uh, in just few minutes or hours. How? Let's take a look. So I'll quickly share the screen, and we'll share the low-code platform which can be used to create this Spark workflow. As you can see in this platform, the left hand side shows some features. For example, this is a dashboard feature. This is for metadata. This is for creating an entity. This is for creating pipeline. You can also see the total number of pipelines that you have created, then the job, then monitoring, and then lineage and other more features. Now on the top menu, it shows a customer orders. This is the pipeline that we have created. This is the config and schedule. This option is specially to switch between the design view and the code view. If you can see the code view, it shows you the code that it has created behind the scene. But as now we are discussing about the low code, no code, we will switch back to the design because we want to hide the code part and we want to just display the design part, which will be visible to the user, not the code part. This is a cluster that is shown here. So I have selected the dev cluster of one node and it's up and running. Now these are the components which can be used for creating entire your data pipeline or the Spark workflow. So here it is having source, target, lookup. Here it has transform, reformat, filter, aggregate. This component is for joining or splitting. This component is custom component, and this component is for subgraph and stuff. So let's quickly create two entities, customers and orders, and we will call it as a source entity. So again, I'll name it as customers. And like I mentioned, we are going to fetch this from the Databricks file system. So I'll choose the data set here like customers. Now, this file that we have is of type CSV. So I'll simply click on next. And here I'll mention the locations of this customer's data that we have placed into DBFS, Databricks file system. Now, as you can see, it's having some path at where we have mentioned we have placed our .csv file. In properties, we need to use user-defined schema. So we have checked this. This file is comma separated, so we have used as a delimiter as comma. First row is header, so we have checked that as well. We are going to infer schema. That's where we have chosen infer schema option, and we will click next. This is the preview part. If you refresh this particular view, the table or the content also will get refreshed and it will display the rows at present in the customers.csv file. It's taking a bit time. I will click on save. Yeah. So as you can see, the configuration that we have made in the customers entity is saved. Now, once we click on play button, it will execute or it will ingest the data to your Spark workflow from your Databricks file system. But still, it's loading. It's in progress. Yeah, it succeeded. So we will click on execute. So the jobs in progress shows 0, 1 out of 2 jobs finished, and jobs is succeeded. So now, if we click on this and if we go to preview, it will show the data over here as well. Yeah, there you go. I close this. Now this is just one entity that we have pulled from the Databricks file system. Now I will create one more entity. I'll call it as orders. This entity, and I'll open the config. Will ask me the data set. I'll give the orders as a data set, and here I will mention file as a CSV. In location, I'll mention the DBFS and this path and the orders data set input.csv. In properties, I will mention use user-defined schema. Delimiter again is comma. First row is header and infer schema, right? In the preview, and I'll simply click on save. So it should save the configuration. Now, once I click on execute, it will load the data from Databricks file system to our Spark workflow. Now, we want to join these two data sets. So we'll import the component called as join. See, we have simply drag and drop this component. I'll connect both these entities. I'll provide these as an input. And okay, so here, as you can see, it has imported 100 customers. Okay, so you can see customer ID, first name, last name, phone, email, and then country code, account open date, account flags. And over here, you can see it has imported 1000 orders. If I click on this, it will show the order ID, customer ID, order status, order category, order date, and amount. Now let's click on the configuration of the join component. Now we need to mention here the joining condition. So we are going to join this two data set uh, with the help of customer ID. So I would simply select customer ID over here is equal to put one dot customer ID. So this is our condition, and in expression we are going to select the target column. Okay, so 0 dot count open date we want. We want customer ID and we want order ID, so which is present in the one order ID. Then we want order amount, which is also present in orders table. So input one dot order. So this is amount. It's displaying in one, two times. We'll remove it. Then we have first name and last name. So first name and this is the last name. So this is what the target column that we have mentioned. Now let me give the alias to this count open date customer ID order ID amount first name and the last name. Right, it's a condition. This is expression. Now let's save this configuration. Yeah. Once it is saved, we can execute it. So the job's in progress and it has completed 2 out of 3. Okay, it succeeded now. So we can see the output here. Okay, but let's import one more component, that is reformat. So we are going to perform the transformation on this join data. Okay, so which will be an input. The join data will be an input for the transformation that we have created. So we'll name this as by customer ID, joined by customer ID, and this component we will name it as a cleanup or probably full name. So we will click on this and import the configuration. Now here we need to mention, we need to calculate first the account length days. We are going to calculate from the date difference function. Here we can mention current date probably. Yeah. And here I think there is just one input, so we need to mention account open date. So this, we will name it as account length in days. Then we will we'll keep customer ID as it is, order ID as it is, uh, amount as it is, and then we will concatenate this two field, that is first name and the last name. We'll name it as a full name, and these will remain as it is. We are not performing anything over here. Order ID, and this is the amount. Right? Yeah, that's pretty much, I think. We will save this. Once it is saved, okay, before that, we have joined this data set, these two data set. So let's have a look at the result after the joining. Yeah. So this is account open date, customer ID, order ID, amount, first name, last name. And we have joined these two data set based on the customer ID. All right. Now let's execute our transformation component. That's full name. Okay, that's finished 2 out of 3 jobs. Job succeeded. Now let's take one more component of aggregation. So amounts, aggregation we are calculating, and orders. Output of your transformation will display 1000 rows. So let's take a look. So these transformation, as you remember, we have calculated account length days. So this is total number of days from which the account was open for the customer. The customer ID, order ID, amount, and the full name. As you can see, first name and last name is concatenated. I forgot to mention the space, but you can assume like if we would have added one more single space, it would have shown the one space between first and last name. All right. Then we will simply open the component for the aggregation. Now here we need to identify on what basis we want to perform the aggregation. So for example, we want to perform, let's say we want to count the total number of orders that customer has placed, right? So, or we also want to find the account length days. So we will will have to select the first of count length days. And like I mentioned, you want to count the total number of orders. So how we can do that? We'll simply mention count order ID. Then we also want to see uh, the total purchase that customer has made, right? So we'll simply sum it up. So we'll sum up the amount, and here we have finally the full name. So I think we can again provide the first and then the full name. Now all these aggregation, all these functions are based on one column, and that column is your customer ID. So we'll mention in group by we'll mention customer ID, and in target column we'll also mention customer ID, and over here we will simply choose account length days as an alias, then orders, then amounts, and here full name. So I think that's about the aggregation. Let's save it, and Before we execute this, let's load this output into target system. So again, we will go to source of target, and then we will drag and drop this target. We'll move it towards end, and we will connect this. We'll open the configuration for target, but before that, let's call this target as customers orders. Let's open this, select the data set as customers orders output, and this is the file. The type of file that we want back is, let's say we want to keep it a CSV file that in which we want to write. So I have selected CSV. The location, again the same location. It's just that here I'm mentioning customers orders.csv, in which the data will be stored, the output data after aggregation. And this is the properties. So in properties, I can mention whether I want to override, whether I want to append, ignore error. So as of now, I want to override my data. So I have selected override over here, and it should write the data based on the column delimiter as comma, because it's a CSV. First row is header. Again, I want header to be written in my output file, and I want to also mention the schema over here. So that's where I have mentioned customer ID, account, then place orders, amount, and full name. Looks good. I'll save, and after saving, it will save the configuration that we have made, and we haven't executed this yet. So I'll execute this aggregate component. Once it is done, it will perform the aggregation on this 1,000 rows that we have transformed, and it will just produce 100 rows out of it. So once I click on this, I can see the result from the aggregation component. So as you can see, like customer ID 1, name is Grace. He has opened his account since this many days. His account is open from this many days. The order ID, the total orders that he has placed is 12, and total amount that he has spent is this. And once this output is available in our workflow, we can write it back to our target system, and let me execute that, the target entity. It's being processed. Seems it is finished. Yeah, it is. Let me take a look. Open. Location. Yeah, so this is the location. If we see at the DBFS Databricks file system, we would be able to see this file holding 100 records, having all the processing that we have done. Like we have performed the joining, then we have performed the transformation, and then we have performed the aggregation. It will consist all those operations, and the data will be present at that particular location. So it's a very simple use case. If we go with the traditional approach, we will take more than 2-3 weeks to develop it and to make it live. But here, with the help of low-code platform, we can build this in just 10 to 15 minutes. Well, that's the power of low-code platform. It's interesting, isn't it? With that note, I would like to pass on to Ghazal. She will walk you through the pros and cons. Thank you.
Thank you so much, Weber, for walking us through the scenario. So now we shall look at the deciding factors, rather those characteristics which would help us understand whether should we make use of the low-code platform or should we continue with the traditional approach. So the first factor is the configurations and settings. So like the name suggests, so we need to identify if uh, the no-code platform that we are going to make use of is going to help us manage the solution independently, as in the configurations and settings, the authentications, permissions, etc., need to be seamless. If that is the case, then certainly we can opt in for this particular platform. Second, second characteristic would be the cloud infrastructure. So, like with the high demand of distributed data and the distributed network, we have the cloud infrastructure and the cloud services that are gaining popularity, right? So, similarly, if the no code platform, if it readily supports for the cloud services and that is the need of our solution, then certainly this becomes another important factor that we need to consider. Thirdly, the flexibility. So now, like I mentioned in my previous slides as well, it's not just the technical experts who are going to make use of this platform. So certainly those with no formal technical training are also going to make use of this, maybe to have, say, the data models in place, or maybe to decide over the strategies, maybe to have some data-centric reports, etc. And all of this, if it is to attend in a small span of time, and if that is the demand, the solution is, like actually looking out for, then certainly flexibility plays another major important role as the deciding factor. Then we have the intelligent automation. So, like in our previous session of the XAI, we see that we are, like heading towards AI and ML these days. So, I believe that it becomes really another important factor to us to consider if the platform, is able to simply automate complex solutions. When it is able to leverage artificial intelligence and machine learning to analyze the data trends to predict the impact of maybe the strategies or the tactical changes that are happening, then certainly this is something really important that we need to consider upon. Then we have the connected operations. So it's ideally that we tend to connect to external data sources, the other web services, or maybe the APIs, or maybe any other integration adapters. So in this case, it is very much important for us to consider this, because we need to ensure that the solutions provide a unified view by integrating all of these disjoint sets. So certainly the connected operations, what I mentioned, also becomes one of the major deciding factors. So for me, maybe as a data architect or data engineer, I would consider these to be some of those deciding factors. But again, it all depends upon the solutions that you are developing, which would help you, take the decisions based upon various other factors as well. So every approach now is associated with a certain set of pros and a certain set of cons. So listed are a few pros or advantages that are associated with this approach. Now, like obviously it's cutting down the development effort by say around 50 to 90%. It means certainly it is faster, it is productive, it is the seamless integration. Or like we mentioned, you must have seen in the scenario that was explained by Webhub. So the integration that has been done by the various data sources, or maybe the file formats, that it's just kind of plug and play that we are doing, right? So that is another important advantage that we have. So we don't have to struggle to write all the connectors and all of that. Then low cost innovation. So when I say low cost innovation, so here the time is invested to think about innovation rather than to sit back and get the actual development of programming done. So these are the set of pros that we have. Similarly, are associated certain cons. So now that this works on the principles of already developed components with a drag and drop, like we say. So certainly, customization here is limited. Second thing, it is very much vendor specific. So like switching between the vendors would definitely be one challenge. Furthermore, since we are not actually coding, we would not have the proprietary rights on the code that is generated, because again we are making use of those components which is being provided by the vendor. And then we have this then we have this uh, data management. So when we say data management, it still requires that um, the technical experts, or the data scientists or the data engineers, we require them still to process the tasks. What I mean to say is businesses still rely on these technical experts for processing the data. It is still not 100% sure that this can be taken care only by this no code platform. Yeah. So these are certain pros and cons that are associated, but certainly I think since this is just an evolving technology, uh, there could be some workaround on the cons that they turn out to be the pros as well. So these are certain facts that I came across while I was studying on this topic. So according to Red Hat, it says that the development time is cut down by around 90%. So low-code platforms have this potential. Then we have Statista, who says that around 33% of the respondents across the globe are making use of this particular platform for data modeling and visualization. So it's gaining high popularity when it comes to the data-centric approach. Furthermore, foresters have made the statement that this platform is around 10x times faster when compared to the traditional software development approach. Certainly, when we have such a lot of development effort getting cut down, it's obvious that it's going to be faster. Then we have this very interesting case study that I came across that was performed by IBM. So IBM implemented this IBM's RPA solution, which is helping in building bots to automate the insurance and financial processes. And interestingly, since it did not really require much of coding, the experts there, or the SMEs who were there, they didn't have to really create. They just had to create these bots to process the data. And interestingly, this solution helped to increase the process execution efficiency by around 80%, and there was no new staff that was hired to support this operation. Secondly, the speed in which the data capture was done, the processing and the delivery to the client, that tremendously increases. And the most important, that was the human error reduction. So due to repetitive processes earlier, there used to be human errors, which here certainly it reduced to a lot more extent. And finally, no code AI is kind of gaining popularity these days. So building the AI models, the training ML models, all of this requires a lot of effort, you can say, or it requires time. So with no code AI, this time is getting reduced to minutes. All right, so that's where the companies are adopting to this no code AI. And Forbes has made the statement that around 83% of businesses say that AI is the strategic priority for their businesses coming forth. So these were certain facts which I thought would be helpful in making you know how low code and no code is gaining popularity. And finally, maybe to sum it up, I would say that the game is changing, and the new player is emerging. So with ML, while it's going to help us identify new patterns out of massive data, and AI assistants will provide timely recommendations, but does that mean that we as the technical experts have no longer to code things here? Certainly not, because the complex mechanisms will definitely require the greatest machine, that is the human brain, to have all the complex processings done, to take a rightful decisions. So the amalgamation of the ML and no code platform is not about proving that humans are useless or that requires no intervention of humans, but it is to maximize the human abilities, I would say. So looking at the benefits with the drawbacks, the deciding factors, and the salient features of this methodology, I think we can affirmatively make the statement that it is not intended to really replace the traditional approach. Rather, it is trying to fit in to this IT industry to leverage its own features, I would say, like the system 2 and the system 1 of brain, that which I mentioned in the first slide, similar concept. So with this, it would enable users to build the data analytics faster and gain deeper insights, cutting down, of course, the development efforts. And the entire premise of this approach is to make the process quicker and simplified by enabling developers like you and me to iterate and prototype with ease. Yeah. So, in other words, maybe to conclude, I would say that yeah, we shall continue to follow the leads of our brains um, to automatically derive patterns and seamlessly offer them whenever necessary. So is that with the low code and no code platforms. So it is just getting started, and you can say that the future is right here. So let us add this up to our tech stack. Yep. So with this, myself, Ghazal, and my co-speaker sign up for this session. Thank you.
That was wonderful. Thank you, Ghazal and Webber.
Hey, have you ever heard of Web3?
Yes, I have, but really, what is it? And why is it on everyone's mind right now?
Well, Web3 represents the next generation of the internet. Now, without giving you any more spoilers, let me call upon Mr. Deepak Batra, who is going to talk about it in detail. Mr. Deepak Batra is Vice President of EXL Digital and spearheading the AI ML solution delivery.
Hi, this is Deepak Batra. I actually lead the advanced automation AI ML led solutions at EXL and work in the capacity of vice president. Thanks, Globant, for giving me an opportunity to actually present an important topic here, which actually is going to be the near future of and then completely disrupting the web industry. As you can see, I'm actually going to talk about Web3 and the role of AI ML, which is going to be played in Web3. Web3 itself is a very nascent kind of a technology which is evolving, and it keeps on evolving day by day, and we never know where this will land. But yeah, we definitely have some viewpoint, and we know that this definitely is going to be the future, and AIML is going to play a very critical role in Web3 once the World Wide Web actually transforms and disrupts, and we all embrace Web3. So before actually talking about the role of AIML, I just want to spend a few minutes on explaining what exactly is Web3 and why we feel that this actually is critical for the organizations and the businesses and also the end users in all aspects in across verticals. So Web3 is nothing but Tim Berners-Lee, who actually was the inventor of web. He typically calls it a semantic web. So what does semantic web means? What does the term semantic means here? Semantic actually means that if we talk about Web 1 or 1.0 or World Wide Web 1 and World Wide Web 2, everything was centralized, which is that everything was put in one place, and then users will have access to that, organizations will have access to that. But when it comes to Web 3.0, then the fundamental principle behind this is semantic, which is distributing all of the data and the end users getting more control on that, which was not the case, or which is not the case when we are actually being we are using the social networking sites or apps, because all of the data is being controlled by the big organizations. Whatever we interact, however we interact within the web, the data gets captured, and that is being controlled by the companies like a Facebook, Twitter, etc. But worldwide Web 3 or Web 3.0 is completely going to disrupt that, and things will drastically change, because one of the other fundamental principle it works on is the decentralized blockchain. So everything gets broken down into various chunks, and the computing is completely decentralized as compared to what we see today, which is completely centralized and focusing only in one location. Data storage is either on a cloud, which is data lake, or on-prem databases, but that completely is going to be changed. So just a quick snapshot of how we have been using Web 1.0 versus Web 2.0 and Web 3.0. I'm not going to cover all of that in detail, but just a snapshot that how we have been used to doing it. So typically, Web 2.0, we all know the dot-com boom in late 90s. That completely disrupted the industry, where everybody, every organization, every business wanted to actually host a website. And that's how the dot-com boom actually came up. That exactly is going to happen in Web 3.0, when we'll see more of metaverse technology and digital worlds taking completely over the way things are driven today. And as I progress, I will actually cover some examples as well, that why we feel that metaverse, digital world, centralized and decentralized web are going to be the future, because centralization definitely has limitations and users do not have control on data, and decentralization will completely disrupt the industry. And first, the B2B industry is going to be transformed typically into a B2C, and then we'll have more control on data, how the end customers, be it in the insurance world who are insured or claimants, be it in the healthcare world who actually are patients, etc., will have more control on what they share as their data, and how we solve for that. And I will cover that. So the point of view or the views on Web3 is as follows. We know that web is already everywhere, and today if we see the disruption we are going through, everybody is having a mobile. We are into the 5G era now, so people are very very well versed with how the internet works, how the apps work. And we have seen some of those examples in the form of startups who actually have been successful because of the evolving technologies. So this, because web is already everywhere and anywhere on all devices, so definitely when we switch to Web 3.0, that definitely is going to take precedence, and it is going to stay everywhere. It is going to evolve and expand further. We have been talking about cloud computing, AI, ML, etc. But how that is going to impact once we step into Web 3.0? The cloud, in my opinion, is going to become more intelligent and more discrete. Even we feel that from an on-prem to a cloud, there has been a massive or a mammoth journey which has been taking place in last couple of years because of the pandemic. But still, the data actually resides within that cloud. It gets restricted, so whatever the users are interacting, uploading, goes into S3. Still, the data is in the control of the organizations and businesses. Users will not have much control on that. So when we talk about intelligent cloud, and that comes over the Web3, then obviously the data control and data kind of restrictions will be more towards how the users are behaving and what users are uploading and sending and interacting on web. Not everything actually will go and will be stored on clouds or on prem, because users will have more control on that. AI ML has been evolving in last few years, and this has become an integral part of all software systems or applications. So this definitely is going to play a very critical and vital role, because now, so today AI ML is being applied once data is available on cloud or on-prem in databases. We extract data out of that, cleanse that data, and filter out the business critical information from that huge chunk of data which is being thrown into systems today. And then if you see, typically there is a 2.5 quintillion bytes of data every day which we generate. And you can imagine the kind of magnitude that if we have to pull out meaningful data out of this 2.5 quintillion bytes, it is actually going to be a mammoth exercise. And that's the reason we see a lot of adoption for analytics and generating insights. But at the end of the day, if you have to generate insight, the first step is to clean the data, because we get a lot of garbage along with what is being uploaded in the cloud or on databases in on-prem environment or setup. And then once the data is cleansed and we get rid of garbage, then we have to eliminate and remove noise out of that. And then we have to apply NLP and figure out what is the business critical field or business critical data which is required to process the transaction in any given business vertical. So when we switch to the Web 3.0, And then obviously in the current setup, then we apply the AI and LP, figure out that okay, how this can be taken forward. But as we progress and as we switch to Web 3.0, in my opinion, AI MLP, AI and NP and ML actually is going to be applied upstream, where the data first time we interact with data, which is when the end user actually is uploading information. That is the point where AI and LP gets applied. So we get rid of a lot of non-value add steps downstream, eliminate a lot of waste already upstream, and reduce the cost of operations as well. And I'll give you an example for that. So let's take an example from an insurance vertical. So today, if an insured unfortunately ends up in an incident, for example, an accident happens, right? So what will the insured do? The insured will inform the insurance company either directly to his or her carrier or through the broker from where the policy would have been bought. So what will the broker or the carrier request? They will request all details about the incident. And who actually, those who are well versed with the insurance industry, they would understand that the kind of data which is being requested and which is being ingested, even to log a claim, which is the first notification of loss, FNOL, it is humongous. And 60% of data is completely non-meaningful, non-value add, but because that's the process the companies have been running their businesses, that is how the data comes. And then there are teams sitting manually to cleanse that data, figure out what line of business the claim has come for, what kind of policy etc is the insurance or insured is having, what kind of coverages are there. Now imagine if we give a simple form to the end customer or the insured through Web 3.0, that okay, if you have to log on first notice of loss, just fill up these 25-30 fields. It may be not as simple as I'm saying, but that's what the end vision and the game should be. So they just do that, fill that information, whatever, and that information is something which is required, minimum information required to at least log a claim. There can be a number of processes after that where the users can actually reach out to the insured, get additional details. But at that point of time, which is the moment of truth, when the insured is already in trauma because he or she has met with an accident, we just can't expect tons of fields and information to be requested from the insured. So just fill that form, submit it. We apply AI and LP there itself, and whatever goes downstream into the systems or into the core admin platforms or through the multiple processing teams sitting there is all meaningful, all da- clean data, and with insights generated. And then if somebody feels, or even if the automation feels that there is something missing, can go back and ask for additional information. So that's typically where Web 3.0 is heading, and that's what my point of view is. Today we talk about Internet of Things. We have seen a lot of IoT devices, right? And we use some. In fact, I use a couple of IoT devices at my home. But things are completely evolving, and things will keep on changing. IoT will become IoE because right now we have Internet of Things. But moment we get into the Web 3.0 with 5G enabled on our cell phones, we actually are going to see the era of Internet of Everything, and everything will be driven through the devices, through the voice enabled systems. And we'll give you another example for that. So let's take an example from healthcare, typically from India. If I get into a situation where I'm not well, and it does not require a physical visit to a physician or a doctor, but what is required is just a consulting. Now there are tons of apps which are available in the market who actually will do a video call and consulting with the doctor, and the prescription is there. But what if there are some advanced tests which already had happened and doctor has to see the reports? What if doctor has to physically, or in a physical virtual environment, has to examine, for example, the throat of the person? So that is where metaverse is going to play a bigger role, which is nothing but the virtual reality. Doctors will have, or physicians will have, those devices where they actually can virtually be available with the patient, examine them virtually. If they have to examine the ear, for example, or nose, for example, or throat, for example, they will have those technology gadgets to actually examine that and go a little bit more deeper to understand that if this requires further due diligence or diagnostics, advanced tests, or a physical visit to a hospital. But right now, we are still not there. It's just a video call or a video conferencing which happens, and that's nothing but we're just talking face to face. Even if I open my mouth on my cam, doctor will not be able to figure out that what exactly is happening in my throat. So that is the kind of a technology and technology interventions and adoptions we actually are heading towards. So that's why I say that it is going to be internet of everything, because people will start embracing it. People have embraced these apps to do physical virtual video calling consultations. I have been doing it quite often, and this also is going to be adopted. Now the question comes, which is I think the critical question and the key question, that how will AI ML and, for example, NLP is going to impact this. So I have been from a background of product development and have been a hardcore techie throughout my professional career. And in 2011, when Mark Anderson said that software is eating the world, what typically it meant was that then also a transformation was happening. I was working closely with some of the UK and US insurance companies, delivering large enterprise underwriting platforms for them. And definitely software was eating the world, because a lot of things were moving from manual paperwork to completely software driven. An underwriting platform where the underwriters or underwriter assistants kind of assistants will actually get information, obviously maybe in a paper filled setting or in an email, and then they start entering that information into an underwriting platform to generate a quote and eventually premium, etc. So that was exactly what was happening in late 2000 kind of after 2010 and the last kind of 10 years. But the next decade is going to be completely driven and ruled by AI/ML. Now we can easily say that AI/ML is going to eat software, and we exactly are seeing, because wherever we are actually working with our client engagements, there's no discussion happening with the CIOs and CTOs of the world where AI/ML is not an important and a critical lever, even if you're trying to solve a simplistic problem, because that is given. And they are dealing with a lot of legacy softwares, legacy platforms, decade old, more than a decade old. So they definitely don't want to move or migrate into a newer platform that would take them millions of dollars of investment and couple of years of time. So what they are looking for is that how can AI/ML bring a difference on the table? Whatever is there, let's keep it, but just figure out that how can AI/ML be applied on top of that and can transform and change the way systems are working. That's why we say, and I'm confident that AI/ML actually is eating software and is completely going to eat the software, because that already is the core building block for any solution, any software, any problem which we are trying to address in the business area. This actually has become a core building block. So what is then web intelligence, which is for Web3? Because Web3 actually comes with three main building blocks. The first one is the intelligent blockchains. We know that blockchain already exists today, but the blockchains are going to become more intelligent as we progress and embrace Web3. We know that there are protocols already available, whether it's an HTTPS protocol or other security protocols, but those protocols are going to become more intelligent in Web 3.0. And we'll see that how that is going to happen as I progress. And then obviously the intelligent apps, and we'll cover what exactly that means. So if we start looking some of these things in a little bit of more detail, so whatever we see in terms of blockchain platforms today actually are largely focused on the distributed computing components. So they just focus on the discrete components of computing which are available, and then they just kind of start enablement of decentralizing those components. And this has already happened in financial transactions. We see that in the stock market big time, and we see that in the excuse me, and we see in some of the other financial kind of engagements and settings. So that already is happening. Now the next gen of layer, which is layer 1, which we call as base, and layer 2, which we call as companion of blockchain, actually will start incorporating the AI/ML driven capabilities. So when we talk about the AI/NLP models or AI/ML models, those are now going to be applied at the time when the decentralization is happening on those on data blocks or on the financial transactions which is happening. So once the end user sees those financial transactions, that already will be something where AI, NLP, ML is applied. And if there is a business need to generate some insights, for example, in the stock market, those insights will be available on the fly. And if something else has to be done, that also will be easily achieved. So that is where the blockchains will become more intelligent, because now we actually are going to apply AI/ML models on top of those distributed computing components, and blockchain will convert to an intelligent blockchain. That's how things will kind of progress, because we'll see a lot of predictions happening. Uh, the way I said that if something has to be predicted, for example, in the stock market, that is going to happen on the fly, and users can take decisions on the fly when they're actually buying or selling stocks. What are the intelligent kind of protocols? So we already have seen the decentralization finance already has happened, which is nothing but DeFi. So that has happened because of blockchain. But now there are going to be smart contracts which actually are going to play kind of key role on the Web3 stack, and that is the point when the Web3 stack will start ingesting and applying some of the models which we have been talking about. Because right now it's only about data, it's only about segmentation of those components, decentralization of financial transactions. But when we apply the models on these capabilities, then we'll start seeing some huge trends in terms of uh, predict kind of predictive analytics or some kind of preventive analytics, etc., which is going to happen. Now, we already know that decentralization of financial transaction has happened, which is DeFi, but there is going to be a next generation of DeFi transactions, which we call as automated market makers, nothing but AMMS. So these are nothing but, for example, lending protocols, right? If somebody applies for a loan today, on the fly, basis the ANLP models, the lenders actually get to know the historic nature and the credibility of the person who has applied for a loan, because of the ANLP already applied on top of that. And they can take decision on the fly that whether the loan has to be granted, approved or not, and if it is has to be granted, if a person is asking for X million dollars of loan, how much has to be granted, and how that will actually fall. So that is where we think that these protocols are becoming more intelligent. And then there are a lot of apps which actually are also offering some wallets, right? So we can always apply some intelligent models, ANLD models, to figure out the score on those wallets, at what kind of transactions are being done by those users, how much money or how much amount is available with these users in the wallets, how they're actually using it, are they actually taking a lot of credit, or are they just able to balance their finance. And all of that actually can be done without getting a lot of information from users, but the information which is already available in engines across the financial world, and can get those intelligence scores generated. Now, the third critical component of Web3 intelligence is the intelligent apps, which is nothing but the decentralization applications. So we have always heard about blockchains as decentralized computing components, but now as we progress into Web3 world, we see that how the applications are going to be decentralized, and I will also cover that how those three broad components are going to be driven once we see a quick, no technical architecture, but kind of a high level architecture of what exactly Web3 means and how AI and NLP can be applied to that. So, and this is going to become very popular and is going to be adopted on a rapid phase. And we already see that in the NFTs, because NFT already is one area where, which is nothing but non-fungible tokens, which actually already has embraced the decentralization applications concept. But the next generation NFTs, where we progress, will also see that how the ANLP models which are applied upfront or upstream, how those insights can be generated, and how we can eliminate the need of data cleansing, data modeling, etc. Because now we do that upfront the moment data hits the Web3 space, and we apply that there only, rather than waiting for the data to be available at a source, be it a cloud data lake, or be it a database in an on-prem setting. So that is exactly what is going to happen. And if you see that quote from science fiction writer William Gibson, he says that future is already here. It's just not evenly distributed. And that's absolutely true for Web3. We see that Web3 is being embraced in some areas, like distributed financial transactions, for example, non-fungible tokens, NFTs, etc. But this definitely is going to be largely and evenly distributed once things are going to be stabilized, because this is still evolving and technology actually is taking its own shape. And we'll soon see this being embraced across business verticals, cutting across verticals, and that day is not too far. Now let's actually peel some layers of Web3 and see that how it will embrace AI ML. And I just want to So it's important to spend and understand the architecture of Web3, because that is how we also will understand that how the AI and ML will be applied once we actually move into the Web3 world and the concept. So what I'm going to cover is a couple of things: a quick architecture, but at a high level of Web3 application, and then the purpose of AI algorithms, that how those are going to impact. So this is a typical architecture of a Web 3.0 application. We today also we have a front end. We'll have continue to have that front end, but then there's going to be a provider between that, and then behind the provider is going to be a blockchain. And these two components are actually big differentiators here, because front end we have today as well, but then provider we have web servers, etc. And then behind those web servers we have either a cloud S3 data lake, or we have some on-prem databases if the setting is on-prem. So these three elements where front-end provider, blockchain are going to play a critical role. The beauty of the architecture of Web 3.0 is that AI and NLP can be applied on all of these three layers. So for example, in the front end, when the end user is interacting with a distributed application, which is DApp, and uploading data or providing inputs, at that point of time, we can actually apply AI and NLP or ML models to figure out and solve for a business problem. Now, if the setting is such that we can't do that because of XYZ reasons, there can be business reasons where for example, in insurance, a carrier may feel that no, I don't want to restrict my insured to only send me business critical information because I need all information from them, which is required for my internal processing. Absolutely fine. Get everything from the front end, and then that lands on the provider. So once that lands on the provider, without even going into the backend, which is blockchain, we can apply AI and NLP on the provider part itself, and then figure out that what exactly has to be solved for. And then we only send the meaningful information into the blockchain, which is nothing but smart contracts on EVM. If for some reason we are not able to apply AI, ML, or NLP on provider as well, because we get some data from multiple systems within the organization's IT ecosystem, and now all of that data which is getting within the organization's IT ecosystem and from the end user has to be combined, and then it should be sent to the backend or in the blockchain to be stored in a discrete or fragmented manner. Then we can just start ingest that data and then apply AI and NLP on blockchain. Now, what exactly happens and what is more meaningful? So I think applying AI and NLP at the blockchain level definitely might not yield big business outcomes, because at the end of the day, we then will be dealing with the same situation the way we are living today, which is we have got the entire data set. Now we have to first figure out and clean that data, understand that data, apply NLP to figure out the business critical information of that, and then apply AI and machine learning models to then progress further or process further. So while we can do that on all three modules, but it is recommended, and as we progress, we'll see that how this technology evolves. This is still an evolving phase. More and more AI and NLP application will actually happen on the front end. That is going to be the key, so that all clean data flows downstream and all the garbage gets removed at the user end itself. And we'll see that how things progress, because this will vary from a business line to business line. Some of the business kind of areas will feel that no, we need to apply at a provider level. There will be some other business areas, for example, in the supply chain industry, they will feel that no, front end is more meaningful and more scalable. So we'll figure out. But in a nutshell, this is how things actually are going to look like. And if this keeps on evolving, then obviously we'll see that how things are evolving here. So the purpose of AI algorithms basically can be of two types. One is the customized algorithms, and the other is general purpose algorithms. So customization always will happen once there is a specific business need to do or create some algorithms or models for the data which is coming through. General purpose is general purpose, and the customized algorithm actually gives an output based on requesters identity, and we have seen that in the YouTube feed. We have seen that in the Facebook feed as well. So if I go to Facebook and start looking for some, if I click an ad, for example, which is saying that you're getting a free credit card, if I click it once, Facebook instantly knows that I have some interest in getting or buying a credit card, which is not having any free, because it's a lifetime free card. So the moment I come out of Facebook and go again, the feed of Facebook actually will be will be in such a manner that I will see more options and more advertisements which are specific to free lifetime credit cards, because I clicked that. That's exactly happening in YouTube as well. So what exactly does that mean? This means that this is actually a customized algorithm, because this is now customized to my business need, and this is customized the way I actually are way I am interacting on the web. Similarly, general purpose is nothing but where spam detection, for example, spam detection, or let's take an example of property insurance. So if the properties are located in a region which is close to a seashore, for example, or which is in a area which is prone to more earthquakes, that becomes general purpose algorithm, because it will upfront tell the insurance provider or the carriers that if there is a request which has come for a new business from this area, then obviously this is a more risk prone area, the premiums have to be high. So that becomes a more general purpose algorithm. And these two algorithm types, while we experience this today as well, but these two becomes more imperative and more important when we talk about web3, because now on web3 these algorithms are directly going to talk to the inputs which the users are going to provide, and users will have control on what they are actually providing. So so that was actually the third layer of web3, and how that is going to be embraced within AI/ML. These are some potential use cases while I've talked about healthcare. So for example, I talked about the physician, right? Let's take an example. And I was going through this problem a couple of years back. My brother was having a rare kind of type of cancer, and I obviously wanted to consult a doctor from a Mayo clinic in the US while I'm residing in India. So I had no other way but to actually send emails to Mayo clinic, send them reports. So there's obviously a lead time. So I used to send them reports and interact through emails. They will actually inform and respond me back after say 3 to 4 hours, and then there's a time zone difference as well. Now let's imagine that we are in the metaverse world, and there are doctors sitting in the US, for example, in the Mayo clinic, who are equipped with those metaverse devices, and on the fly they actually bring me into a virtual reality setting, and they're able to talk to me in a virtual reality setting, and I'm able to talk to them in a virtual reality setting using metaverse technology on web 3.0. This completely will transform my experience, uh, and and the way I actually want to interact with these healthcare physicians, because now that barrier which is there is completely broken. The barrier of time zone, the barrier of that lead time between me sending reports, they responding back and asking for additional information, everything is now then going to happen on the fly. So that's typically one potential use case once we actually get into the era of web3, and then we start embracing metaverse as well. AI/ML is going to be the fundamental building block, no doubt about that. Life sciences, same kind of concept. When we are into a pharmaceutical industry, how things actually are there in terms of drug supply chain, and we have seen that in pandemic, how there was shortage of drugs, and how people were actually struggling to get some life saving medicines. And if we actually would have kind of a better I would say supply chain mechanism using data analytics and AI/ML, then definitely it would have been easy for us to figure out that okay, which particular area, zone, region requires more drugs versus which requires less, and that balance happens. While in the pandemic, a lot of companies came up with those models, but then we still feel that there is a lot of potential already available in the life sciences in these use cases. Financial services I already have talking about. Like I just spoke at how things are completely transformed in the stock market, and people obviously can get information on the fly if they are selling or buying stocks, that what exactly is happening going to happen with their investment and with their money, and they can take meaningful and wise decisions basis those insights which are generated. Supply chain, same example, the way I was talking in the healthcare, that applies to all supply chain, the entire supply chain industry, and the supply chain kind of organizations can manage their storage warehouses in a very I would say meaningful and better way, and they can save some cost as well. Amazon has been using this big time. Same is with other big app providers like a Flipkart in India, for example, or a Walmart, which now has acquired Flipkart in India. So they actually use some of these potential models big time to one, save cost, to understand the business need, and then fulfill the customer demands and needs as soon as possible. So on the closing comments, or to conclude what exactly is going to happen. So recently I was just going through an article where the Seoul metropolitan government actually has declared and has completely, very confidently has said that they have a vision plan in 2030, and they actually would want their city to be the first major city to embrace metaverse on Web3 using AI/ML. And so what that means is that they actually want to completely transform the entire city, and they want all of the industry verticals to actually use metaverse, and they already are working on that aspiration, and things are progressing. So the intention obviously is to build an environment where the end customer gets a lot of flexibility, gets things at scale, and that scalability comes at a speed. So today, if you have to deploy something, that obviously will have a lot of repercussions and a lot of, I would say, prerequisites to that. But when we actually do things at scale and that scalability comes at speed, that is what true transformation actually is going to happen, and that is what true transformation will make sense for the end kind of users and customers, and organizations will see this change happening soon. So this actually is going to be the power of Web3 with AI/ML. If you just go with Web3, which is 0.99 to the power of 365, the result is in front of you. But if you just add AI/ML to that and compound that, and then the compounded result is in front of you, 37x more outcomes, 37x more benefit, 37x more speed, and this is how the industry and the organizations around us are completely going to change and disrupt. So whatever is happening in today's setting as B2B, most of these things actually will be converted to B2C, because now in Web3 we'll see that how the users are able to control the data which they are actually sending onto the web, and how the organizations are kind of making more sense of that data, so that B2B thing will actually be transformed into a B2C setting. That's all I had for today. It was and Globant, thank you so much for giving me opportunity. Thanks for watching this, and this is evolving. So as we progress, I definitely will get a chance. If I get a chance to again speak on this, I will come with an evolved version of this. Thank you so much.
Thank you, Deepak, for the insights. With projections for humongous volume of data, it is observed that the current data platforms will have several architectural failures that might hinder the enterprise data processing and inhibit business growth. While big data technologies like Spark and Flume are able to handle data at high volume, they have failed to address the scale and other dimensions.
Data Mesh addresses these dimensions, and our next talk is just about that. Let me tell you a bit about Sonal and Burhan. Sonal is a business intelligence leader at Globant, having a strong experience of 12 plus years in the fields of big data, data warehousing, and BI. While Burhan is a data architect at Globant and has overall 12 plus years of experience in big data and legacy database.
Hello, everyone. Good morning, good afternoon, and good evening, depending upon where in the world you are and what time you are hearing this. So, today we are here to talk about one of the most happening buzzwords, the data mesh, right? And we would want to understand more that whether it's one of the emerging frontiers for our next data strategy, how effective it is, and how different it is compared to our traditional approaches, right? When and where should you consider this, and when and where should you not, right? So let's go ahead and start with our session. So the first topic obviously is data mesh. There's a lot of news around going decentralized to centralized, or whether again going to decentralized. But then how does it help in solving the real business challenge, right? When we say yes, with data mesh, we are going to do domain driven design, we are going to have some governance, we know all of these areas. But when it actually comes to designing, what is the ROI that we can expect out of this architecture, right? How well it is suited to meet our problems? What about the turnaround times? So these are some of the areas that we would like to bring it up and talk about it. And the best way to do that is to start with a business case, right? A real world problem that we have faced and we have solved. So let's consider one of the domains, which is advertising world. Simple, yet but very complicated. Trust me. Simple for the audience or the receiving people, but very complicated when it comes about to ad management, ad placement, publishing industry, bidding, competition, the KPIs, right? So yes, we will talk about one of the famous M&E client, which happens to be into the advertising industry, and what are some of the challenges that they faced, and how did we overcome that? Also, data mesh is about, it's not a technology or design. It's more of a mindset or a paradigm shift, right? It's more of a practice. So when we say paradigm shift, but where and how do we do that? Right? That is one of the important questions that we should ask ourselves. So we are here to throw some light on that as well. Now, we've been talking about and listening about and reading about data mesh. But then, do we also know that what it is not? And which are some of the scenarios that we should definitely consider whether we should apply data mesh to it or not? That I would say is one of the most important areas in the entire paradigm, right? And then concluding our session with what is the next call to action or way forward from here. So when you leave this talk, you know what to look for, right? Okay, so moving on to the best way to get started to reach somewhere is to begin. So data mesh, right here, if you look at these pictures right now, what is it that you see here, right? You can send in your answers to us in the chat box. Yeah, I understand there are a lot of advertisements to the left side versus none to the right side, and how the world is so colorful and engaging when we see these advertisements to our left, and when we know what we want to buy, when we have our friends and family pointing it out, demanding for things. So that's how the engagement gets created when we look at these ads, right? That is the world that we see when we see these ads, right? And versus how plain and boring it might become when you don't have these recommendations or ads popping up in your devices or your gadgets, correct? Yes, that's the difference. But I do see one more thing here, and I would say thousands and millions of dollars spent on the left side versus not on the right side. Yeah. Okay. All right. So let's look at and try to understand what are some of the challenges that come with this advertising world. As I said, it's very simple and easy to understand when we are as an audience, right? But it becomes very complicated and challenging for the advertisers, because what they have to do and worry about is a lot of things, right? How to understand the audience segment better, what ad and when should be the timing of the ad when I play it will get me most of the traction or engagement, right? If we talk about these surveys, only 14% of the organizations have achieved a 360-degree view of their customer. Now that, to be honest, is very low, right? I mean, think about it. We don't know about our audience that well. We don't know about our audience segment. How are we going to propagate our ads? How are we going to publish our ads in the right manner to ensure that we get the most of it, right? Did you also know that 90% of searchers like you and me haven't made up our minds about a brand before even we start our search? It's actually when we pick up our device and we start scrolling through that some of the ads that come to our screens is where we start getting engaged, and we start realizing that, oh yes, this is something that I really want to consider or look at or buy at, right? Again, Forrester, right? If you look at their service, 42% of the marketing decision makers have agreed that if there is more augmentation in the whole digital analytics world, it is going to improve your campaign responses and outcomes. What do you mean by campaign responses and outcomes? When you run a particular ad, the kind of attraction that it gets, or the engagement, your click throughs, your forwards, your clicks, right, and ultimately to your buying opportunity, generates these revenues. These are ad revenues, right? That means your campaign was successful because you were able to reach to your audience and connect so well. So analytics itself is such a big world, and if we have deep dive into this, then obviously it is going to help us a lot. So think about it in this way, right? If there's a typo error in terms of setting our monthly budget into any one of the famous vendors ads, and let's say instead of $50 we end up putting there $500, the entire month's budget, imagine how much it is going to be. It's going to cost us so much of money and nerves, right? And how do we prevent such situations, such anomalies, such data issues? It's all via your augmented analytics, your alerts in the system that will help you highlight these areas. Gartner predicts that by 2025, 75% of the stories will be automatically generated using augmented analytic techniques. See, advertisement world to me is not a storytelling world. It's in fact a story building world. What they build is what we see and buy, and that is what connects us so closely to them, right? So how important it is to build the right kind of story where we can connect with the audience. Customer engagement, chatbots, evolving privacy regulations like GDPR and all of that. All these have time to time effect on the strategies that we develop and we run through. Right? Poor data quality and data issues, data governance, unwanted access, fraudulent traffic, all those, this is so bots, right? All this is going to cost us and ultimately impacts in our ROI. Did you know that there was a study conducted by Google which found out that more than 56% of the ad impressions are not even seen? Right? Now, that's quite a number if you ask me. Yeah. So, how do we deal with these challenges? So, these are some of the very common problems that any advertising agency faces, and the same happened with our customer as well. So, moving on to ahead, right? The traditional approach to solve these kind of problems is that you start with building the solution before even going in depth in terms of why we are doing that. What is the ROI that we are going to get out of it, right? So if we look at this very specific business use case, this client was very heavily technology driven, with business product or owners involved at the initial or the final stage, right? And also, so our typical SDLC starts with the business owners or the product owners entering the first stage where we talk about requirements and we generate our documents, we start building pipelines, we start extracting data, transforming it and loading it into our warehouses, staging, and then any change that is needed is again incorporated into the same, right? And that is what we don't realize, that over a period of time, this whole journey or transition from the input from the stakeholders all the way up to the data scientists or the analytics world generates some kind of gap. And that is the gap which ends up between the operational data and the analytical data, right? And in the end, that you see that at times you're not able to connect the dots, that how did this reach up or bring me up to this level? And these are some of the problems which are common, right? The gap between the operational and analytical data. There are a lot of siloed teams that work, right? When you have these requirements flowing in, you will have your development team, your testing team, your production support team, your UAT team, all working in their own zones, in their silos, and kind of passing through the information from one group or team to the another, getting their part done, and then again passing it on. So this whole cycle of intelligence continues, right? The data is acquired, executed, transformed, given it finally for the massaging, and reaches to the visualization layer. Decisions are being made, right? And this cycle of intelligence continues. What is more important is the data availability and integration all through this while. And also, as you evolve, as the architecture evolves, you realize that this has become so complex, and there's so much of pipelines now that how do you evolve, right, out of this? How do you make sure that whatever has been built all this while and is still flowing through our final layer is correct? And if there is any change that I need to push in, how will that happen here? The alignment or synchronization between different teams starts to fade away after a certain point, right? And then, as I said, response and adoption to change becomes very limited, and the flexibility is also compromised. Correct? So then how do you deal with this? So the way our traditional approach works is that what we do is we first collect the requirements, build our pipelines, have our warehouse smarts in place, right? And then ultimately generate analytics out of it, get the insights that are needed, correct? But then think about it in this way. What is it that we are missing here, right? One of the main areas is that this becomes very highly specialized technical team's job, right? It's a lot technical here. We are talking about the tech stack. We're talking about how the data will flow. We're talking about how the data will be consumed. But somewhere, while drafting this whole data strategy, we have missed out on the functional aspects of it. We have kind of sideline the whole business aspect to it, right? The whole product approach to it, where we are now just talking about data moving from one area to the other, right? There are technical layers and there are specifications with less or minimal or zero reference to business. So then how a business side of the team is supposed to interpret and understand this, right? We have moved or come to a long way, but what about back to the basics, starting from there? How do I interpret this? How do I trust this data that what has come all the way up till here is the one that I was looking for, right? So it's become very highly technical oriented with business impact, which might be very low, but at the same time technically complex as well, to be able to sustain and evolve, let's say, over a decade. Correct? Yes, so that is one of the drawbacks that I would say, which ultimately we end up being in. It's a harsh truth, but that's the truth that we have to face it. Having said that, what are the other options available, right? So here on, I would like to pass it on to Burhan, who will walk you through some more insights about this and how can we overcome some of the challenges here. Over to you, Burhan.
Sure. Thank you. Thank you, Sonal, for giving us the background about the ad industry, the challenges what are being faced in the ad industry, and one of the solutions being suggested. I'll move back one slide, please. What I see here means solution suggested is one of the solutions which has been already implemented into the industry. But also rightly mentioned by Sonal, there are certain challenges which are also being mentioned on the screen. One is the domain knowledge is only specific to the source teams. Data engineers are not aware what the functional side of the uh, domain is. They don't have any idea why they are doing a certain activity. They just get the inputs, they work on it, and then they try to deliver the results. Same way, so data engineers are blocked in a way. Consumers, in the same way, are completely dependent on the data engineers and the sources. By the way, the domain owners as well, the producers of the data, they don't have a direct say how they want the data to be. Means they have to be happy with whatever data is being available. There is a gap. So what can be done in this situation? So one of the way, what we'll be discussing here now, is a solution. What is the solution? We can implement data mesh. What is data mesh? That will be your one of the question what you all will be having. So data mesh is actually a principle, an architecture which is based on four principles. What are these four principles? Let's first discuss that, and then I'll show you how it can be implemented. The four principles are: distributed, decentralized domains will be created. Second is it will have a self-service infrastructural platform which can be utilized by consumers, by producers, to automate their entire work, means they don't have to worry about how things are going to happen. They'll just provide the inputs in a very uh, easy, simple to understand UI, and from there things will be all automated, which will happen automatically in the background. Third is data as a product. So we are going to you so data becomes the product. So how we are going to utilize it, how it becomes the most important part in this entire infrastructure architecture, is something what we are going to discuss. That is the third principle, by the way. And the fourth principle is federated governance, where we can decide on whether the governance should be handled centrally, or every domain will have its own governance mechanism. But these are some of the uh, parts of data mesh. Now let's look at how the architecture will look like. So this is how it will look like, way different from the traditional approach, where here we are creating domains for each and every important product. Each domain will have its own ETL process. The benefit of this process is data engineers are not doing all the work. They are not responsible for working for all the different domains, but every domain will have its own ETL team who knows about the business very well, and who knows about the requirements, who knows what consumer actually needs, and will give the most effective solution, the most effective results, which can directly be consumed by the consumers without any additional transformations or modifications. Second, self-service infrastructure, where you don't so consumers and producers don't have to worry about how the design will be created, what all processes has to be created, but it will all be automated in the background. Use the infrastructure in user interface, it will capture the information from you, which will create the necessary infrastructure in the background, and all the ETL jobs required for that specific domains will work automatically, will be in place, and will start giving you the results. Third thing, data as a product, we already discussed. Fourth thing is federated governance. So now, as I mentioned, we can have a central governance for all these domains together, managed centrally, or we can have governance at each domain level, which can be maintained separately. There will be an additional cataloging activity will be required, because consumers, how they'll get to know where the data is, what the data is all about, what the columns are within the table, a particular table. So all this information will be stored in a catalog, from where they can access this information. Consumers can access this information very easily and utilize it for their own use cases. I'll move to the next slide, where what are the principal actors now to achieve this functionality, to achieve this data mesh infrastructure. So we have data product owners or builders, who is going to provide create the data, produce the data. We'll have engineers, maintainers, who will be part of that domain itself, and they will be doing all the transformation activities, and will be providing you with the providing consumers with the final data set. And then there will be consumers who will be consuming the information for BI, for analytics, for data science. It can be anything, visualizations. And so these are the three principal actors. What is the success outcome means? Why should we implement data mesh? Am I going to get anything out of it? Yes, you are. You will be, so business will be able to make better decisions by implementing this data mesh architecture. We are creating a data driven culture, because each domain will have its own processes in place. It's a product, by the way, and everything will be driven by data. Data science team, analytics team, AI team, now, because they are also part of this domain, they already know how the data has been from where it has been produced, how it has been transformed. They'll be able to do better analysis, better uh, uh, they will be able to execute machine learning algorithms on it in a better way, because they also know about data in and out. Fourth is, it will also improve data quality, because we have mechanism here, governance mechanism in place, which will make sure right data is only being shared with right people, as well as right data is only being made available into that particular domain. Organization will be able to respond way faster to the emerging regulations, which is ever changing. And last is, data products and or domains can be created whenever there is a need, without impacting the previous domains what are already created. Whenever you see that there is something important which can be considered as its separate product, let's create a domain for it, and it would be very easy in the data mesh architecture, which may not be so easy if we are following the traditional approach. So these are some of the success outcomes. It's a paradigm shift, by the way, because you are moving away from the centralized ownership. Instead, you will only be, so here it's the complete focus is to have decentralized ownership where each domain will be responsible for their own data. From monolithic design, we are moving to a distributed design. From the pipeline based architecture, we are moving to a domain based architecture. So it's not a single pipeline, not a single data engineering team who will be responsible to do all the activities, but a separate data engineering team for each domain. Instead of data as a byproduct, now we are focusing or giving more importance to data itself. So we are considering it as data as a product. So our data becomes our product. And from siloed data engineering team to cross-functional domains where each domains are connected with each other. They know from where the data they are supposed to get the data, and they don't have a dependency on a single data engineering team. So this is a shift, paradigm shift. Now there are some do's and don'ts. Data mesh, because it's a buzzword, everyone wants to explore. So it's not something which can be explored by everyone or all the organization. So let's also discuss what data mesh is not. Data mesh is not just a technological focused solution. What data mesh is, it's a complete change in thinking. It's organizational, cultural, technological paradigm shift. How we are going to manage and share the data with each domain or with the consumers. It's not just the decentralization, but you have to follow all the principles, all the four principles of data mesh to make it a data mesh architecture. It's not just a data lake or a data warehouse, but what I feel is it's hydrology of interconnectedness between producer and the consumer. It so what does we mean by it? Means data lake and data warehouse can also be part of each of this domain. It's not that we are moving away from data lake or data warehouse, but we are utilizing data mesh, data warehouse technology into each domain, and then we are creating some results which can be consumed by the consumers. And it is not for everyone. By the way, it is not for small organizations. It is only for organizations which are mature enough, who understands that it's a big change, and the risk associated with implementing the data mesh within their organization. What are some of the common watchouts? It can result in data duplication, because it may be possible that each domain is trying to do the same activity, and they are not aware about whether the other domain is also doing that activity or not. Governance, now because governance, if we are going with federated governance, distributed governance, where each domain will have its own governance, it will require additional resources. You'll require uh, more people to govern this data for each domain, may result in additional cost, additional requirements, additional maintenance, management, lot. Cross domain analytics. So now here, because everything has to be self regulated, self service, we need to create cataloging activities. We need to provide a way by which consumers will be able to search and access this data very easily. So all these things has to be created separately, which is a time consuming and a costly task. Cost and risk, by the way, already covered within the previous 3 points, where cost is attached, risk is also attached. If it fails, then everything has to be started from scratch. And it's a change management where a lot of things will be required from change management perspective. Decentralized approach has to be followed. uh, um, Governance team has to be created. So an entire change management team will be required, who will be focusing on all these changes. With this, what I will do, I hope I was able to provide you all the information with respect to data mesh. I tried providing the do's and don'ts as well. What are the common watchouts? Now I'll pass on to Sunil again to discuss about the go forward. Over to you, Sunil.
Thank you, Burhan. That was excellent. So wonderfully explained that what are these some of, apart from what data mesh is, what are some of the key points to, watch for, and how to ensure that what we are doing is also aligned to what we want to do, and not just do it because it's the new modernized architecture that we want to adopt, right?
Yeah.
Yes. So, what is our call to action and way forward out of this discussion? Right. So, the most and the very important one is don't miss the point and fall fast for different schools of thought. This has been going in terms of how architectures have evolved and how they will continue to evolve going forward as well, right? But what is more important for us is to understand that looking at our current architecture, what has been built over the last decade or more than that, how we can either upgrade that or how we can redesign it. But at the same time, what we are going to do with it is also something that it can adapt to, right? That's a very important point to not forget. So every change has a cascading impact to what has been already built. Even the slightest of change can, bring a tsunami of the downside changes to it, which can impact a lot, right? Other area to consider is shifting our mindset from the top level questions to the hyper specific queries, right? That is one more area that we should consider. We should ask ourselves very specific in terms of what are we trying to achieve from this, what kind of collaboration is needed while we do this, right? See, data mesh is altogether a cultural shift, right? It has to start and accepted right from the management layer up until the product owners, product teams, and the technical teams. And that's how it is a cross collaboration, and the responsibility lies within each of these stakeholders to get through there, right? Knowing that 45% increase, which we see in our analytical reports, ain't going to be sufficient hereafter, right? Understanding why it happened is equally important to know that now. What influenced to get these 45% increase, right? Or a decrease, right? We have to start thinking on those lines very well. So that is again one of the areas that we should really consider when we are evaluating what kind of design will work for us and why we should go for that design, right? See, architectures will evolve. Traditional, modern architectures are going to continue to be there, and it is all dependent on what problem statement we are trying to solve, right? If we look at EDWs, Enterprise Data Warehouse, they are excellent at fast writes, right? The traditional extract along with the dimension modeling approach built over a larger time frame may take good amount of time for business to see the results, but at the same time it's worth the wait, right? You get to see your analytics, your visualizations, expose that data to your data scientists and other stakeholders and get them access to that. Whereas in data mesh, data accessibility becomes one of the major areas, your major selling points now, because the product team is so involved, so closely coupled. The concept of domain itself is so strong because the product and the technical team now work together and move beyond technical, but more of looking at the data as a product. That's one of the important points in terms of collaboration and how it reduces the overall integration or flow of data right from the ops till the analytics. It does help to close or bring closer the ops to the analytics data gap as well, right? So discoverability, accessibility, integrity is something that gets revealed by following these practices in data mesh, right? But also we should make a point to consider that when we are starting to expose data as a product, what is it's going to cause, right? We should make sure that it's not going to impact any of the existing or break any of the compliances, right? We are not we are making sure that we are compliant with the data regulatory laws and acts at the same time. So governance is what becomes a very important part here and plays a major role. opting for targeted, robust, and automated architecture. This is what will ultimately help us to maximize our ROI on the spend that we are making, right? A robust design will go a long way through, right? Now, when it comes to data mesh, there's one more concept of having clear boundaries or data ownerships between different people involved. So that's the whole bounded context that we talk about. But we should also make sure that at some point, this bounded context or data ownerships shouldn't become a problem later, because now it's very much in terms of the scope that we are localizing, right? So governance, data as a product, producer consumer relationship, right? Scalability, and the blending of data with the right set of knowledge coming from stakeholders to the technical team, and then bringing the two closer together is what is going to be the success factor when you start to evaluate and weigh the option of considering data mesh, right? But not to forget the traditional approach as well, which gives you some leverage in terms of your traditional structure of building your pipelines, integrating it, and making it a centralized structure where all the information is available at one go, right? So it's quite something to compare in terms of what strategy you should go for, but it all boils down to one of your core problems, right? We started with the problem of advertising and the challenges that advertising world faces today. So when we talk about all these strategies and architecture, does it mean that how and where should we stop? No, it does not, right? Stopping to invest in advertising is like asking your watch to stop showing the time. That's not the way forward. Instead, take a pause, assess what is it that you need from and how is it that you're going to get from it, right? Consider each and every stakeholder that's involved in this, because that is where the blind spots are, which will get highlighted, and that is where you'll be able to decide what works best for you, which may not work best for others, right? So that was all that we had to share. We really thank you for your time.
Thank you, Sonal and Burhan, for your insights. Let's play a quick game where we will ask you a set of questions based on the conference topics, and the winners stand a chance to win exciting prizes and goodies from Globant.
This will be a fastest finger first round, and you'll have to type in your answers in the chat box. Whoever gives the right answer first gets the point, and the winner will be announced at the end.
Okay, so here's the first question. Which XAI, explainable AI tool, did you see in action today? I'll repeat. Which XAI tool did you see in action today? The right answer is SHAP, WIT, or LIT. Next question.
ML algorithms are often skewed because of dash in data. I'll repeat myself. ML algorithms are often skewed because of dash in data. So whoever gave the answer as bias is going to be the correct answer.
Okay, here goes the next question. The smart sheet is used for. The next question is, the smart sheet is used for. And hint, it is from the low code, no code session. And the right answer is process workflow automation.
The next question is, which tool can be quickly used to build and deploy UI? Which tool can be quickly used to build and deploy UI? And the correct answer is Power Apps.
Okay, here goes the next question. Well-defined governance is an important feature of data mesh. True or false? I'll repeat. Well-defined governance is an important feature of data mesh. True or false? And the answer is true.
Here comes the next question from Data Mesh. How is ownership different in Data Mesh? I'll repeat. How is ownership different in Data Mesh? The correct answer is decentralized ownership.
Okay. The next question is, how much has Globant India grown in the last 4 years? I'll repeat. How much has Globant India grown in the last 4 years? I'll give you a hint. Our year-on-year growth is more than 50%. The answer is more than 200%.
Let's come to the last question. How many cities in India are Globant offices present? Once again, how many cities in India are Globant offices present? What did you guess? The correct answer would be 3: Pune, Bangalore, and Ahmedabad. So this brings us to the end of this fruitful exchange. We, Shikha, Sanket, Priya, were your hosts, signing off. Hope you enjoy the rest of your day. Thank you.
Thank you.